सुरमोहनाकारणे ॐ शरणं शरणं वरगणपतिये शरणं शरणं करिमुखदोडेया शरणं शरणं शिवसुत बेनका शरणं शरणं श्रीगणनाथने वरदातने परमानन्ददायक गजमुखने 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 ಧನ್ಯವಾದಗಳು.
Thank you, Arshita. It was indeed divine. This conference addresses the rapid strides and technological advancements currently witnessed in the fields of computer science, information technology, electrical and electronics and communication engineering. To set the tone for today's conference, I am honored to invite Dr. Chandrasekhar M. Patil, Professor and Head, Department of Electronics and Communication Engineering, to formally welcome the August gathering.
A very good morning to one and all present here. It is with immense pleasure and honor that I welcome you all to the inaugural function of Asia Pacific Conference on Innovation in Technology 2024. It's truly a privilege to share this occasion with such a distinguished assembly of individuals. First and foremost, I would like to extend my heartfelt welcome to our esteemed chief guest, Dr. Shayan Srinivasa Garani, Professor, Division of EECS, Electrical, Electronics and Computer Science, Indian Institute of Science, Bengaluru. Your presence here adds great significance to our event, and we are deeply honored. A warm welcome to you, sir. We also have with us Mr. Robin Verma, Vice President, Commercial Banking, Wells Fargo, Hyderabad. Your presence today enriches this event. A warm welcome to you, sir. I am pleased to welcome our Honorable President, Shri Gundappa Gowda. Your guidance and strategic leadership have been pivotal in shaping the direction and success of our institution. A warm welcome to you, sir. I also extend a warm welcome to our Honorable Secretary, Engineer Shri P. Vishwanath. Your organizational acumen and commitment to excellence are truly commendable. A warm welcome to you, sir. We are also delighted to welcome our beloved Principal, Dr. B. Sadashiva Gowda. Your leadership and vision have been instrumental in guiding to reach new heights. A warm welcome to you, sir. I extend a very warm welcome to all the deans, heads of various departments, representatives from IEEE and session chairs of today's conference. Welcome you all. I would also like to welcome Dr. Nagaraj BG, Associate Dean, Research and Coordinator of this conference. Welcome you, sir. I also welcome Dr. Ashok Rao, former Head, Network CDT Product, IISc Bengaluru. Warm welcome you, sir. I also welcome Dr. DJ Ravi, Principal, MRIT. Warm welcome you, sir. I also like to welcome all my dear colleague friends and all the participants from different institutions. Together, we have gathered here eagerly to embark on this journey with all of you. Thank you all for being here and for contributing to the success of this conference. Once again, a warm welcome to each one of you present here. Thank you.
Thank you, sir. On behalf of the organizing committee, I wholeheartedly welcome you too. As a symbol of growth, nurturing, and our commitment to the environment, we have chosen to commence today's event with a ceremonial watering of the plant. This act signifies our collective dedication to fostering growth, sustainability, and a brighter future for all of us. To formally inaugurate this conference, I would like to invite our esteemed dignitaries to water the plant. Thank you all. One of the most significant moments of our conference is the release of the proceedings. This document is a comprehensive completion of the research, insights, and knowledge shared during this event. It stands as a testament to the hard work and dedication of all the contributors and serves as a valuable resource for our community. To mark this special occasion, I request all the dignitaries to officially release the proceedings of Asia Pacific Conference on Innovation in Technology 2024. Thank you all. As we gather on this significant occasion, it is essential to set the context and provide an overview of what we aim to achieve during this conference. I request Dr. Nagaraj BG, Conference Coordinator, Department of Electronics and Communication Engineering, to give us a comprehensive overview of this conference, its objectives, and the statistics of this conference.
Good morning, everyone. Respected dignitaries on the dais, of the dais. It's a pleasure to welcome you to the Asia Pacific Conference on Innovation in Technology, APCIT 2024, hosted by Department of Electronics Communication Engineering, Vidyavardhaka College of Engineering, Mysore. APCIT addresses the technological advancements currently witnessed in the fields of electronics and communication engineering, computer science, information science, artificial intelligence and machine learning, and electrical engineering. As we gather for this exciting event, I would like to share some remarkable statistics that reflect the scale and impact of this year's conference. Firstly, we received a total of 2,234 papers from researchers around the globe, and we have used Microsoft CMT manuscript submission system. We are proud to note that papers have been received from 21 countries, including prominent contributors from the UK, Australia, China, Philippines, Sri Lanka, Bangladesh, Peru, Indonesia, and many more. After receiving the papers, we conducted plagiarism and AI score detection using Turnitin software. If the plagiarism and AI content were less than or equal to 20%, we sent the papers for blind review. Otherwise, we did the desktop rejections. Our conference has also benefited from the expertise of 534 reviewers from premier institutions and renowned industries, who have evaluated the submissions, ensuring that only the most impactful and well-researched papers are featured. After a rigorous peer review process, 288 papers have been accepted for final presentation, so resulting in an acceptance rate of 18%. This competitive rate highlights the high quality and relevance of the submissions we have received. The conference will be conducted in hybrid mode, combining both physical and online sessions to accommodate a wide range of participants. We have planned a total 4 physical sessions and 33 online sessions, providing ample opportunities for engagement and knowledge sharing. Additionally, we have 37 session chairs from across India, each contributing to the smooth and effective running of our sessions. I look forward to the engaging discussions and valuable insights that will emerge from this conference. Thank you all for your participation and contribution to making this conference a resounding success. Thank you, one and all.
Thank you, sir, for that insightful overview. Knowledge is power, information is liberating, education is the premise of progress in every society and in every family. True to which, on this occasion, we are extremely delighted to have the eminent scholar, a powerhouse of knowledge, our chief guest, Dr. Shayan Srinivas Garani, Professor, Division of EECS, Indian Institute of Science, Bangalore. He is a renowned educationalist whose work has inspired countless students and educators alike. May I now request Dr. Ashok Rao, former head, Network CEDT Department, IISc Bangalore, to come forward and introduce our esteemed chief guest to the gathering.
Good morning, everybody. Namaskara eldrigu. Introducing Shayan is one reason I told I will introduce, because I don't want to read from printed CV, because the printed CV misses all the interesting things. Okay, yeah. So having said that, we're very glad you are here, Shayan. And Shayan did his master's in Florida State University, Gainesville, University of Florida, under Principi, whose book we read in spectral analysis. And he did his PhD in Georgia Tech under McLaughlin, who's world renowned. Okay. And he worked in San Diego, SanDisk, is it? Oh. ST Microelectronics and Western Digital. Your hard disks of Western Digital, his patents run on that. And then by some coincidence, he shifted to India. He came and joined my department, CEDT. And Professor Sadashiv Gowda was talking to him about which department he is. So I must also check, because I will tell you the navigation. He started with coding, 3D coding on barium titanate crystals or whatever you were talking, holography coding of digital data. Then the first thing he did was, all of us know how difficult error control codes are. He is one of the world leaders in 2-dimensional error correcting code, which is 10 times more difficult than one-channel error correcting codes. And I think he has already saturated that, so he shifted to something more. He did enough machine learning, but more than machine learning, he is among the top 5, if not the top 10 in the world in quantum computing. He has produced the most impressive results from whole of Asia in the field of quantum computing. And not just that, he has produced a remarkable paper on music and mathematics. It's a very rare journal which publishes maybe 2 issues a year, and I don't know, 3 years it took, the review process. It took 3 years for them to review world-class work, and with partnership with another interesting fellow from Kuvempu Nagar, Harish Sheshadri, who is a mathematics faculty in IAC. So he did his B in JC, I forgot to mention that. Mysore has produced lot of talented people. Mysore is a very creative place. It's not a productive place. You don't make big money in Mysore, but very, very creative. A lot of people are very creative out of Mysore, but we don't seem to harness or get them more frequently. Harish is another interesting fellow. So the only good work that gets done is when X talks to Y. If X1 talks to X2, no good work will come. So I just wish all the department walls are dissolved so that people here can talk to anybody and try anything funny. And one of the reasons that paper on music of mathematics is, he's very good in maths. I have not seen many engineers who are as good as maths, and he's a worthy replacement of the Don of maths called Vital Rao, whose course he continues in IAC now. And why he did music well is, he's a grade A vocal artist in All India Radio, so he could actually make a career out of music too. And I don't know what he's trying out now. Let me know what you're up to next, and I will try to at least make sense with that. I have reached a stage where, or rather, you have reached a stage where I cannot catch up with you. Thank you very much. It's such a pleasure to have you here.
Thank you, sir. It is indeed an honor to have such a distinguished educationalist with us today. I request all the dignitaries on the dais to felicitate our today's chief guest, Dr. Shayan Srinivas Garani. Thank you all. May I now request our today's chief guest, Dr. Shayan Srinivas Garani, to address the gathering.
So first of all, it's a great pleasure to be here for two things. So Mysore is my birthplace, so it is always a pleasure for me the moment I cross Ring Road and I get onto this Bangalore-Mysore freeway. There is a sense of joy that thrills me, right? I mean, and the moment I cross Srirangpatna, it fills me with wanting to reach Mysore as fast as possible. So the freeways are great. In 1 hour, 1.5 hours you can reach. So it's a pleasure to be here in Mysore, birthplace. Second, it's a pleasure that I got the introduction from Dr. Ashok Rao. He didn't mention about my bachelor's thesis. So, I mean, he did everything else, but I just waited, and then he didn't start in that order, but I'm going to complete that. So my BS thesis was under the guidance of Professor Ashok Rao, and it was on wavelets, speech and image compression through wavelets. He didn't tell me about that. In fact, I teach multi-rate signal processing, a lot of which from my undergraduate material I teach at the graduate level for IAC students. And so this is, my association with him is from, 93, ever since I joined JC, 93, 94, 93 to 97 when I finished my undergrad there. So, his lectures on fractals, chaos and things like these, evening lectures. Not in the usual hours, but 6:30 to 7 o'clock, and this is where it inspired. And when all the friends were busy with their projects, we had completed everything, and we were chit-chatting with him about reading research papers and things like that. And that is the key thing for a lot of things that he spoke about the rest, and that ingredient was missing. I felt and I want to kind of chip in that, and hats off to Professor Ashok Rao, who has given a foothold for many UGs and inspired them, and I think I happen to be one of them that took inspiration from him. So it's a great pleasure to be here, to see all of you, on the dais and off the dais, and for this conference, an Asia Pacific conference on innovations in the technology. So one thing about this Asia Pacific conference, I mean, I must tell you that, Cambodia, I think I visited Cambodia in 2014 sometime for an Asia Pacific conference on signal processing and, communications and things, which even P.P. Vaidinath and others were there. So, and it was a historical city, and I hope that this conference happens in Mysore, historical place in India, and then, you find a lot of international crowd, top crowd that come here, that you are able to host them, and it beams with activities. So I think coming to innovations and technologies, I think today we are in an interdisciplinary world. So a lot of things, as Professor Ashok Rao mentioned, it is not compartmentalized. I think earlier when I was during my engineering days, things seemed to be compartmentalized, even today to some extent. But you see, the barriers are being broken. Now, the AI is now getting onto the quantum, and from quantum, I don't know, finally, eventually into the, trying to understand at the nano level and also understanding at the astronomical levels, and this may be the pursuit of how humankind will move in this direction. So I think, sciences and engineering, I think all the STEM areas, they are all coupled and they are all interlinked, and it is very important for us to foster the spirit of scientific temper and innovation as we develop new technologies, and these technologies will reinforce our understanding of sciences and the world around us. Okay, so with this, hopefully, I think this conference will evolve into a bigger one, and hopefully there will be many more such events that are going to be happening in Mysore, the historical place. And I wish this is the cradle of education and things like this, the state of Mysore, and I want great success for this conference. I wish the conference participants a grand success, and the organizers too that have taken the effort, and I wish you all enjoyable time for this conference and whatnot. So thank you.
Thank you, sir, for your insightful words. Today, we also have with us Mr. Robin Verma, Vice President, Commercial Banking, Wells Fargo, Hyderabad, as our chief guest. He has been a driving force behind numerous innovative initiatives and has consistently demonstrated excellence in his field. I now invite Dr. Chaitanya DJ, Assistant Professor, Department of Electronics and Communication Engineering, to introduce Mr. Robin Verma to the gathering.
It's a great privilege to introduce today's chief guest, Mr. Robin Verma, VP Commercial Banking, Wells Fargo, Hyderabad. He has completed his bachelor degree in computer science and a postgraduate degree from CDAC. He is an industry expert and stand out as a distinguished data engineering, analytics and data science leader with more than 2 decades of experience in banking and financial services. He currently serves as Vice President at Wells Fargo, where he leverages his expertise in data strategy, governance, and engineering to drive business transformation through data-driven decision-making. He has expertise in many fields like data engineering, analytics, data science, data quality, and ML for data analytics. His remarkable journey includes working for Wells Fargo, Barclays, TransUnion, Citibank. I am deeply honored to share about his achievements on his stage. He is renowned for strategic leadership in transforming business through data-driven decision-making. He has developed effective data strategies and achieved operational savings through innovative data solutions. He advocates for analytics culture, data quality, and augmented intelligence in transforming banking. He was invited as a judge for various US-based leadership programs. He is also a senior member of IEEE and a fellow of IETE. He is a key contributor to the Early Talent Program Committee, and also he recruits top talent from India premier colleges such as IIT and NITs. Thank you, sir, for accepting our invitation and being here with us.
Thank you, ma'am, for that comprehensive introduction. We are honored to have him here with us today. I request all the dignitaries on the dais to felicitate Mr. Robin Verma. May I now request our chief guest, Mr. Robin Verma, to address the gathering.
So first of all, a very big thanks to Chaitanya for giving a detailed introduction about me. I think she covered everything what I wanted to start with. Yeah, thank you very much. And yeah, good morning everyone. Thank you for inviting me here today. So before I start, I just really want to tell you that, I was not aware that I'm going to sit with somebody like Shayan, who is so well known in the industry, in his field. Yeah, I'm really honored to be sitting next to you, sir. So before I start, I want to say a disclaimer. I'm not here to represent my company, Wells Fargo. Okay. So I'm here as an industry expert who have worked around across the globe, and how I can share my insights and my work experience, which can helpful for all the dignitaries over here and as well as the students of this college. So to start with, I hope you all had a good breakfast and are as excited as I am. First and foremost, I would like to express my gratitude to the Vidya Vardhaka management, our respected principal sir, the entire faculty team, and of course, to my young engineers. And to be honest, when I was under the impression that this is going to be a mix of so many different branches, but I got to know when I entered in this college, the most of the crowd is from electronics, because it is connected with this one is connected by electronics department. So the moment I heard the college name, Vidya Vardhaka, I found it so meaningful. So Vidya means knowledge and Vardhaka means enhancer. So it's a knowledge enhancer which resonates with very essence of what education should be. A continual process of growth and enlightenment, empowering students to achieve their fullest potential. Before I move ahead, I know that Mr. Patil told me this is only going to be a 5 minutes thing, but I think I requested him to give me 10 minutes, please, because that's how this schedule came to me as a 10 minutes, then it reduced to 5 minutes, but by the time I prepared my speech already. So as someone who is in the industry for the last 2 decades and has the opportunity to work across different countries, I'm here to share some valuable learnings and thoughts. I have had the chance to work with both IT service providers as well as the product-based companies. So that gives me a very broad perspective. Today, companies like Accenture, Infosys, Capgemini, they all work with me as our vendors, and we have a very close interaction to learn from each other. So I see a blend of generations here today. Baby boomers, Gen X, millennials, Gen Y, Gen Z, and soon Alpha will be knocking the doors of this college. So each generation brings new changes and perspectives. You all worked incredibly hard to reach this point. So this is, I'm talking about the students sitting on the background. After completing your degrees, most of you will enter the job market. Some will pursue higher studies, and others may venture into entrepreneurship. You might be wondering how to stay industry ready with rapidly changing technologies at the current moment. In our times, we had limited branches to choose from. Now, curriculums are tailored to meet industry demands. Thanks to the significant shift in our education system. Today, you have courses related to AI/ML, deep learning, computer vision, and many more. The fields that are high in demand. The pandemic has brought a massive cultural shift in both education and industry. Along with technical readiness, you must also work on your soft skills. The world after college is different, my friend. You need to learn, unlearn, and relearn, which means embracing a change. Consider how technology has evolved in the last decades. Before calculators, we used to have a slide rule for mathematicians and the scientists to do arithmetic calculations. And I remember When I joined engineering, my father told me, you are very lucky you got calculators. We have done calculations manually with a slide rule. And by the way, my dad is like a BE mechanical from Pet Chandigarh. 50s and 60s, calculators and mainframe computers transformed basic arithmetic and complex data processing. 70s and 80s was the era where the personal computers knocked our doors. 1990s, internet became publicly accessible and revolutionizing communication. 2000, the high-speed broadbands, internet, and smartphones like the iPhone combined telephony computing into a pocket. And 2010 to present, wireless technologies with Wi-Fi, 4G, 5G has made high-speed internet availability to all. And not limited to that, AI and machine learning are transforming industries by making systems smarter and more efficient. These examples show how rapidly we are changing. Remember, it doesn't matter if you run, walk, or crawl. Just keep moving forward. If you can run, run. If you have to walk, walk. If you have to crawl, crawl. The important thing is to keep progressing. Take the example of developing a new skill. Initially, it may felt like you are crawling, but with persistence, you will walk and eventually you will run. Also keep in mind that life is a marathon and not a sprint. When you start your careers, it might be tempting to rush and achieve everything quickly. However, it's the steady, consistent efforts over time that lead to long-term success. Just like preparing for a marathon, you need to build your skills and endurance gradually. It's not about who finishes first. It's about enduring and finishing strong. Be ready to learn new technologies and solve the problems that others shy away. That's a mantra I'm telling you from the IT industry. Learn from everyone and around you because there is always someone better than you. Most problems have already been solved by someone else. So you don't have to reinvent the wheel. Focus on new challenges. There are two ways to learn: by making mistakes or by learning from others' mistakes. Which is the more easier one? Spend your time on new and unsolved issues. Another essential skills which you definitely need for the students is networking. Stay connected with your alumni, attend meetups, and reach out to people who you believe can help you in your career on the LinkedIn. Some will respond, some won't. Don't get disheartened. Stay updated with the industry needs. It's working. If your initial year at work, focus on learning as much as you can about your company and about your role. Strive to become indispensable, or what we call as a linchpin. Everything else will follow. Always ask why when in doubt. It's a saying that the man who asks a question is a fool for a minute. The man who does not ask is a fool for whole life. I hope that you all have heard this. So this applies to all phases of your life. So Jensen Huang, who is the CEO of NVIDIA, so I hope that everyone here knows the NVIDIA company. They have made a remarkable journey in the last 4 years. They have changed the world with their GPUs. So he once said, I want you to remember, if it is got a big opportunity, if it's got really hard problem, if it's going to make a huge impact, the chances are it's not going to be easy, it's going to take a long time. You can't rush the process. You have to do the job you can at every step of the way. The best advice is crucial for understanding the value of perseverance and patience in achieving significant goals. The Indian IT market is growing up rapidly. top IT companies are rushing to open their global capability centers in India. They are creating numerous employment opportunities. There will be a tug of war for talent in India. So be ready to ride the wave of that growth. Finally, dream big. Dare to dream big because everything is possible. Don't let anyone take your dream away. Steve Jobs, the CEO of Apple, he said at its best, your time is limited, so don't waste it living someone else's life. Don't be trapped in the dogma, which is living the results of other people's thinking. This is especially important in today's paced world, the fast-paced world. It doesn't matter where you come from. In fact, the more disadvantaged your childhood, the more difficulties and challenges you face, the stronger you become. To wrap up, I want to leave you with this thought. Your journey doesn't end when you leave these college gates. It begins. Whether you choose to run, walk, or crawl, remember that every step counts forward. Life is indeed a marathon, not a sprint. Stay curious, stay resilient, and never stop dreaming. Once you achieve your success, do not forget to give back to the community. Be a part of offering help to your institute and new engineers who look up to you. And by that time, you may find Vidyavartika a deemed university. Thank you and wish you all the best.
Thank you so much, sir, for your enlightening and thought-provoking speech. May I now request our beloved principal, Dr. B. Sadashivegowda, who has been a beacon of inspiration and a driving force behind this conference, to address the gathering.
Good morning to all of you. Today's distinguished chief guest, Dr. Shayan Srinivasa Garni from Indian Institute of Science, Mr. Robin Verma, our Honorable President, Sri Gundappa Gowda, the Honorable Secretary, Engineers P. Vishwanath, Dr. C.M. Patil, Dr. Nagraj, all the distinguished invitees, jury members, and all the participants, and my dear students. Let me, at the outset, I would like to congratulate the Department of Electronics and Communication Engineering for organizing this Asia Pacific Conference on Innovation in Technologies. This is the first of its kind in our institute, being organized by the ECE department in association with IEEE. And all of us know that technologies have been changing the way we lead our life. It could be in the healthcare, it could be in the education, it could be in the manufacturing. Everywhere, technologies have made inroads, and some technologies were highly disruptive, others transformed the life. Both, when you look at the technologies, they have had both advantages and disadvantages. And some of the technologies that cause disadvantage are, for example, if you look at the deep fake, both with videos, with voice, it is very difficult to identify which is authentic, which is not authentic. And it is causing a lot of problems in the society. Similarly, if you look at the social media, that is also causing a lot of problems. 2 days ago, it came in the newspaper that because of social media, the younger generations are spending so much of time on social media, India might lose out to other countries. Even though we say that our youth, we have the biggest youth population, because of higher screen time, or there would be huge economic losses to our country. So this is the dangerous side of technology. So we have to use the technology to our advantage. For that, we have to again find solutions to those problems. Because when they invent technology, for example, when the atom bombs were invented, it was not meant to put the bombs on Nagasaki and Hiroshima, to harness the technology. But many a time we also use it for the destruction. So I believe that technology should be used to enhance the quality of human life, the quality of this planet. But many a time it is causing a lot of destruction. You look at the plastic. When it was invented, it was a boon, but today it is a bane. So as engineers, it is very important that we look at the both pros and cons of every technology which we develop. At the same time, we have to educate the society to ensure that these technologies are used for the benefit of the mankind. So I believe that the deliberations in this conference will throw light on both the good things about the technologies and as well as the bad things, and how we can translate or convert dangers to our advantages, which is also equally important. Also, I would like to thank both the chief guests. Both are distinguished in their professions. I don't know how Mr. Robin Verma knew that we wanted to become a university, indeed. So you said it rightly, that within 3 to 5 years, we are aspiring to become a university. Hopefully it happens. And I wish every one of you a very joyful, informative, and useful conference. Thank you all.
Thank you so much, sir. May I now request Engineer P. Vishwanath, Honorable Secretary, Vidyavardhaka Sangha and ex-Mayor of Mysore, to address the gathering.
Good morning, everybody. I am very happy to associate myself in this inaugural program of Asia Pacific Conference on Innovative Technology. Respected President Shri Gundappa Gowda on the dais, respected Chief Guest Dr. Shayan from IAC, Mr. Robin Verma, an industrial expert as he called himself, rather than his Vice President Commercial Banking in Wells Fargo, respected Dr. B. Sadashiva Gowda, Principal, Dr. C.M. Patil, HOD, ENC, Dr. Nagaraja, BG, Associate Professor, EC, Mr. Mohammad Anis, Assistant Professor, and especially all the invitees and jury members. I will not go to the details because the program is itself for the about the conference. As currently the advancements in technology, especially in the IT branches, so-called CSIS, artificial intelligence, electrical, electronics, and there is so much of discussion is going to be there, and there's so much of papers is going to be discussed. I'm sure. Let us follow Mr. Robin Verma's word, keep progressing, so that we will be able to reach. And as the students who leave the college, they start this journey beginning. I wish the conference all the best. Thank you.
Thank you so much, sir. I would now like to request Sri Gundappa Gowda, Honorable President, Vidyavardhaka Sangha and a devotee of Ramakrishna Ashrama to deliver the presidential address.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಅಖಂಡ ಮಂಡಲಾಕಾರಂ ವ್ಯಾಪ್ತಂ ಚರಾಚರಂ ತತ್ಪದಂ ದರ್ಶಿತಮೇನ ತಸ್ಮೈ ಶ್ರೀ ಗುರುವೇ ನಮಃ. ಈ ದಿನದ ಮುಖ್ಯ ಅತಿಥಿಗಳಾದ ಮೈಸೂರವರೇ ಆದ ಅದರಲ್ಲೂ ಗೋಕುಲಮ್ಮನವರು, ಯಾಕೆಂದರೆ ಅವರ ಮೈಸೂರಿನಲ್ಲಿ ಗೋಕುಲಮ್ಮ ಅಂದರೆ ನಾವೆಲ್ಲ ಅಲ್ಲೇ ಓಡಾಡಿದವರು. ಶೈನಾ ಶ್ರೀನಿವಾಸ್ ಗರಿಣಿಯವರೇ, ಇನ್ನೊಬ್ಬರು ಮುಖ್ಯ ಅತಿಥಿಗಳಾದ ರಾಬಿನ್ ವರ್ಮಾರವರೇ, ಸಂಸ್ಥೆಯ ಕಾರ್ಯದರ್ಶಿಗಳಾದಂಥ ಶ್ರೀ ಪಿ ವಿಶ್ವನಾಥ್ ಅವರೇ, ಸಂಸ್ಥೆಯ ಪ್ರಾಚಾರ್ಯರಾದ ಡಾಕ್ಟರ್ ಬಿ ಸಾಸಿಗೌಡ್ರೆ, ವಿಭಾಗದ ಮುಖ್ಯಸ್ಥರಾದ ಡಾಕ್ಟರ್ ಸಿ ಎಂ ಪಾಟೀಲ್ರವರೇ, ಡಾಕ್ಟರ್ ನಾಗರಾಜ್ ಅವರೇ, ಡಾಕ್ಟರ್ ಅಶೋಕ್ ರಾವ್ರವರೇ, ನಮ್ಮಲ್ಲೇ ಪ್ರಾಚಾರ್ಯ ಆಗಿದ್ದಂಥ ಎಚ್ ಡಿ ಆಗಿದ್ದಂಥ ಡಾಕ್ಟರ್ ಡಿ ಜಿ ರವಿ ಅವರೇ, ಎಲ್ಲ ವಿಭಾಗದ ಮಹಾ ಮುಖ್ಯಸ್ಥರೇ, ಉಪನ್ಯಾಸಕರೇ, ವಿದ್ಯಾರ್ಥಿನಿಯರೇ, ಈ ಒಂದು ಕಾರ್ಯಾಗಾರ ಭಾಳ ಯಶಸ್ವಿಯಾಗಿ ನಡೀಲಿ ಅಂತ ನಾನು ಹಾರೈಸ್ತೀನಿ. ಪ್ರತಿ ವರ್ಷವೂ ಸಹ ಈ ರೀತಿ ಕಾರ್ಯಾಗಾರ ಆಗ್ತಾ ಇದ್ದರೆ ಬಹಳ ಜನಕ್ಕೆ ನಮ್ಮ ಸಂಸ್ಥೆ ಬೆಳೀಲಿಕ್ಕೆ ಭಾಳ ಅನುಕೂಲ ಆಗುತ್ತೆ. ನಾವು ಈ ಸಂಸ್ಥೆ 1949ರಲ್ಲಿ ಶ್ರೀ ಕೆ ಪುಟ್ಟಸ್ವಾಮಿಯವರು ಮತ್ತು ಅವ್ರ ಸ್ನೇಹಿತರು ಪ್ರಾರಂಭಿಸಿದಾಗ ಇರುವಿನಲ್ಲಿರ್ತಕ್ಕಂಥ ಚಿಮ್ಮಿಯಾರ್ಚ ಛತ್ತೀಸ್ಗಢದಲ್ಲಿ ಹೈಸ್ಕೂಲನ್ನು ಪ್ರಾರಂಭಿಸಿ 1975ನೇ ಇಸ್ವಿಲಿ ಈ ಒಂದು ಪ್ರದೇಶವನ್ನು ಇಲ್ಲಿ ತಾಂತ್ರಿಕ ಕಾಲೇಜ್ ಮಾಡಬೇಕು ಅಂತೇಳಿ ಕೆ ಪುಟ್ಟಸ್ವಾಮಿಯವರೇ ಸರ್ಕಾರದಿಂದ ನಿವೇಶನವನ್ನು ಜಮೀನನ್ನು ಪಡೆದು ಮಡಗಿದ್ರು. ನಾವು 1997ರಲ್ಲಿ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜನ್ನು ಪ್ರಾರಂಭಿಸಿ ಈಗಾಗಲೇ ಸುಮಾರು 26 ವರ್ಷ ಆಗಿದೆ. ಪ್ರತಿ ವರ್ಷವೂ ಸಹ ನಮ್ಮ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜು ಪ್ರಾರಂಭ ಆದಾಗ ಡಾಕ್ಟರೇಟೇ ಪ್ರಾಚಾರ್ಯರಾಗಿ ಯಾರು ಡಾಕ್ಟರೇಟ್ ಇರಲಿಲ್ಲ. ಈಗ ಸುಮಾರು 100 ಜನ ಮೇಲೆ ಡಾಕ್ಟರೇಟ್ ಇದ್ದಾರೆ, ಪ್ರಾಚಾರ್ಯರಾಗಿ ಡಾಕ್ಟರೇಟ್ ಇದ್ದಾರೆ. ಪ್ರತಿ ವರ್ಷವೂ ಸಹ ನಮ್ಮ ಸಂಸ್ಥೆ ಭಾಳ ಯಶಸ್ವಿಯಾಗಿ ನಡೀತಾ ಇದೆ. ಒಂದು ಸಂಸ್ಥೆ ಯಶಸ್ವಿಯಾಗಿ ನಡೀಬೇಕಾದ್ರೆ ಬಹಳ ಮುಖ್ಯವಾಗಿ ಆಡಳಿತ ಮಂಡಳಿ ಜೊತೆಗೆ ಅಲ್ಲಿ ಪ್ರಾಚಾರ್ಯರು ಮತ್ತು ಉಪನ್ಯಾಸಕರು. ಎಲ್ಲಿ ನಮ್ಮದು ಸುಮಾರು ನಮ್ಮ ವಿದ್ಯಾಸಂಸ್ಥೆ 10 ವಿಭಾಗ ಇದೆ. 10 ವಿಭಾಗದಲ್ಲೂ ಸಹ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಪ್ರಾಚಾರ್ಯರು ಉಪನ್ಯಾಸಕರೇ ಅವರ ಸಹಕಾರದಿಂದ, ಅವರ ನಿಷ್ಠೆ ಪ್ರಾಮಾಣಿಕತೆಯಿಂದ ಎಲ್ಲ ವಿದ್ಯಾಸಂಸ್ಥೆಯು ಭಾಳ ಯಶಸ್ವಿ ನಡೀತಾ ಇದೆ. ಈ ಒಂದು ಕಾರ್ಯಾಗಾರ ನಾವು 2 ದಿವಸ ಕಾರ್ಯಾಗಾರನ ಇಟ್ಟು ಮಾಡ್ತಾ ಇದ್ದೀರಿ. ಈ ಕಾರ್ಯಾಗಾರ ಭಾಳ ಮುಖ್ಯವಾದ ಕಾರ್ಯಾಗಾರ. ಯಾಕೆಂದರೆ ಎಲ್ಲರೂ ನೀವು ಪೇಪರನ್ನು ಮಂಡಿಸ್ತೀರಿ, ಹೊಸ ವಿಷಯವನ್ನು ನೀವು ಚರ್ಚೆ ಮಾಡ್ತೀರಿ, ಹೊಸ ವಿಷಯ ಗೊತ್ತಾಗ್ತದೆ. ಯಾಕೆಂದರೆ ನಾವು ಒಂದು ಕಡೆ ನಾವೇ ಇಬ್ಬರೇ ಇದ್ಬಿಟ್ರೆ ಹೊಸ ವಿಷಯ ಗೊತ್ತಾಗೋದಿಲ್ಲ. ನಾವೆಲ್ಲರೂ ಸೇರಿದಾಗ ಹೊಸದಾಗಿ ವಿಷಯ ಗೊತ್ತಾದಾಗ ನಿಮ್ಗೆಲ್ರಿಗೂ ತಮ್ಮ ಜ್ಞಾನಾರ್ಜನೆ ಹೆಚ್ಚಿಸಲಿಕ್ಕೆ ಅನುಕೂಲ ಆಗುತ್ತೆ. ತಾವು ಮುಂದಿನ ವರ್ಷಕ್ಕೆ ಭಾಳ ಅನುಕೂಲ ಆಗುತ್ತೆ. ಅದರಿಂದ ಈ ಒಂದು ಕಾರ್ಯಾಗಾರ ಯಶಸ್ವಿಯಾಗಿ ನಡೀಲಿ ಅಂತ ಹಾರೈಸಿ ನಾನು 2 ಮಾತು ಮುಗಿಸ್ತೇನೆ. ನಮಸ್ಕಾರ.
Thank you so much, sir. As we near the conclusion of this inaugural ceremony, we would like to express our heartfelt gratitude to everyone who made this event possible. I invite Professor Mohammad Anis, Assistant Professor, Department of Electronics and Communication Engineering, to deliver the vote of thanks.
A very good morning to one and all. I deem it a great privilege to represent the Department of Electronics and Communication Engineering as I stand here today on behalf of the organizing committee to thank all those who have contributed to the success of this conference. I would would like to express my profound gratitude to our esteemed chief guest, Dr. Shayan Srinivasa Garani, Professor, Division of Electrical, Electronics and Computer Sciences, IAC Bangalore, for kindly accepting our invitation and gracing this inaugural function. Thank you, sir. I would also like to extend our heartfelt thanks to Mr. Robin Verma, Vice President, Commercial Banking, Wells Fargo, Hyderabad, for gracing the occasion. Thank you, sir. My sincere thanks and gratitude to our Honorable President, Sri Gunda Pagoda, for his gracious presence. Thank you, sir. I would like to express my heartfelt gratitude to our Honorable Secretary, Engineer Sri P. Vishwanath, for his gracious presence. Thank you, sir. I am thankful to our beloved Principal, Dr. B. Sadashivegoda, for his guidance, mentorship for the success of this conference. Thank you, sir. I am also thankful to our beloved HOD, Dr. C. M. Patil, for his constant support and guidance for the success of this conference. Thank you, sir. I extend my heartfelt thanks to Dr. Nagaraja BG, the coordinator of this conference, whose dedication and coordination were crucial to the success of this conference. Thank you, sir. I extend my sincere gratitude to the deans, heads of various departments, IEEE representatives, session chairs, and participants from various colleges. Special thanks to Dr. D.J. Ravi, Principal MRIT, for his presence. In his absentia, I also thank Dr. Ashok Rao for his constant support throughout the conference. I take this opportunity to thank all the reviewers, organizing committee, the teaching staff of ENC department, student volunteers who have contributed significantly for the success of this conference. My sincere thanks to the non-teaching staff and attendants of the ENC department for the pleasing venue setup and making all the necessary arrangements on time. As we conclude, let us take the knowledge and connections we have gained here and continue to drive innovation and excellence in our respective fields. Thank you all for part of this conference. Thank you.
Thank you, sir, and thank you one and all. I request you all to stay back for the keynote address by our chief guest, which will start very soon.
ಆಮೇಲೆ ಆನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಎಲ್ಲ.
ಏನು ಕಾರ್ಡ್ಲೆಸ್ ಮೈಕ್ ಕೊಡ್ತಾರೆ.
ಹೇಳಿ.
Mode, or you can switch off. Kind request to all of you to keep your mobile phones either in silent mode or you can switch off your mobile phones. It is a privilege to have so many esteemed individuals gathered here today to share knowledge and exchange ideas. One of the highlights of our conference is this keynote address, which sets the tone for our event and provides us with valuable insights and perspectives. We are incredibly fortunate to have an outstanding speaker for today's keynote address, Dr. Shayan Srinivasa Garani, Professor, Division of EECS, Indian Institute of Science, Bangalore. May I now request Dr. Shayan Srinivasa Garani to take over.
If I think it will be better if I'm more mobile. So if you have the collar mic, that will be good. On your campus, and this is I think the second or the third time I'm here. I was for other visits and stuff. So today's talk is going to be on towards universal quantum computation. I was thinking what is the topic, and Shokrav suggested that I talk about quantum computing. So I'm going to cover this. This is based on some recent works. that were published in Physical Review A and APCIT 2024, then recently in Symposium on Information Theory, based on the work of my PhD student, Abhi Kumar Sharma, who is listed here. So I'm going to talk about that. And so Patil told me to keep it, maybe some math and along with the generality of stuff. So I'm going to cover a little bit of general feel and outlook towards quantum computing, and then I will funnel into the areas which is going to be the heart of this thing, so that people can appreciate what's happening. Does it move forward? Doesn't go? Okay. So I'll just cover a little bit about the background and motivation towards all of these. People are talking about quantum. Most of you must have heard about this, right? Quantum computing, quantum communications, quantum whatnot, right? Quantum sensing, metrology and things like this. I'm going to talk about a little bit of that. So, and then funnel into the areas specific to quantum, universal quantum computing. So I will cover these topics about what is universal quantum computation, then I'll talk about the motivation to this in terms of magic state injection circuits. Then I will get in the details about the geometric view of magic state distillation, which is the heart of the technical content that I'm going to talk to you about. Then a little bit of information theoretic feel for what this magic state distillation is, some quantum coding aspects, and then fault tolerant computing and stuff like this. So there may be a bit of jargon that you may hear, not jargon, some technical things, but I don't expect you to understand and digest every little bit of that detail, but the goal is to get some things in your head so that when you want and you're interested in these topics, you can always go back to the papers and things, and you'll be able to appreciate what's happening here. I have difficulties in this. All right. So broadly, where does this all fit in, right? When you think about quantum science and technology, where is it that we are headed, right? So the classical computing paradigm started from Turing's work, right? This is where this idea of a computer that there's some data which is written on a tape, and this Turing machine kind of goes and reads through this data from these devices, and it processes this information, and then this whole idea of stored program on a disk and reading that the program executes, you fetch the data, you execute, and this evolved naturally in the computing framework. But and today's computing paradigm, I think it is now shifted into more this cloud computing and whatnot, edge computing and all of these things that we think about, where you're fusing sensory information directly across the edges, and then you're kind of doing computation on that. But Feynman said some time back, there's a lot of room at the bottom. That means if you go to the low level states, such as states of atomic states, or states of an electron, or states of a photon, could you harness information at that level? It seems intriguing, right? I mean, it is, you have a spin of an electron, or you think about the number of charge in a quantum dot, or things like this. So there's information out there at those levels, right, beyond the mesoscopic physics. So this is where quantum kicks in. Okay, one side is the macroscopic level and astronomical levels, where you see these celestial levels, and then you come down, cross this mesoscopic physics boundaries, and then you're at the quantum level, at the electron level, at the spin level, or the photon level that you're thinking about, and this is where that you can do computing. Okay, but it's not easy to do computing at the quantum level, because the states are going to be extremely fragile, and therefore there's a reason why we need to kind of bring in all of these ideas towards building such quantum engines. I'm going to tell you where this is going to be helpful. So quantum science and technology pervades in all of these areas, like the way we think about classical, right? If you think about classical information, you have these applications in classical computing, classical communications, right? Classical sensing, yes, of course, you're reading, any information through a sensory device that you can plug it to a system. And that is all classical sensing. But now we are looking at scales at the quantum level, very, very small, high precision instrumentation that we can build, measure magnetic fields in the order of 10 power minus 14, orders like these. And this is where quantum things come in. And the speed at which we can work with, right? That's where quantum computation. So quantum science and technology pervades into quantum computing, okay? Next generation computers which can be very fast to do simulations at the biomolecular levels, which will take years, possibly ages to do that on a classical machine, which is based on the Turing paradigm. Then quantum communications. Quantum communications is quite different than the way we think of classical communications, because if you think of two aspects, one is security. Already I think this BB84, BB92 protocols are now being implemented. You must be aware of this, that is already there in as part of the secure systems. So this is the heart of security lies in when you're working with quantum systems, anything that you meddle with disturbs the state, and because of the disturbance you can detect the presence of Eve, which you cannot do so with certainty in the case of the classical paradigm. I think this is a key thing in the security part, which was actually published in 1984 in a paper by in 1984 by Bennett and Broussard, and it was in Bangalore. And of course Bennett also won this special prize recently. So, and then the other side of it is entanglement. Entanglement is something which is very weird and very different than the classical paradigm. And how can we think of harnessing entanglement and things like that's the heart of quantum communications? And if I told you that I had two broken water pipes, and if you had two broken water pipes, I could not receive information at the destination, right? Imagine there is a source which is having two different sources, two different water pipes, and you connect them, and that's destination. Of course, if these two are broken, you don't receive anything, right? Classical information flow works the same way. If you have two broken links, you can't pump in information out there. But through quantum, two broken links can give you something out there using quantum communications and using entanglement assistance. And this is the heart of all quantum communication. So superdense coding, quantum teleportation that you can do, teleport states from one place to the other place is the heart of quantum communications. But of course it is not at superluminal speeds, because everything is bound by measurements for reconciliation, so it doesn't cross superluminal limits. But yes, you can use this to have send information really at high speeds and do computation. So this is the heart of quantum communications. Quantum sensing, this is all metrology. What you think of signal processing in the classical world is now in the quantum side, it is metrology and sensing, magnetometers, gravimeters, bolometers, and all of these type of things, devices where you want to measure very, very, very sensitive fields. And tomorrow you wouldn't be surprised if people can probe the brain through encephalograms, with very small magnetic fields and sense these changes what are happening than what we are seeing today, and that requires quantum sensing. Okay, next we are talking about AI is going to be anchoring both classical quantum and stuff like that. You can think of quantum AI. People are already talking about quantum machine learning and stuff like this. So that may also be a kind of thing that is going to be there, pervading everywhere from finance to things. So other quantum applications. And you would also not be surprised, because there is, within our DNAs and things like this, there's a lot of quantum things that are also happening. We do not know and we don't perceive what is happening. The photosynthetic phenomenon is quantum. Okay? How leaf produces. And tomorrow if you are inspired by that and come up with an artificial leaf which is going to be really something spectacular, I wouldn't be very surprised about that. I think something needs to be done. So these are all the kind of areas where quantum naturally pervades into. And when you think about the technologies, we are talking about quantum superconducting, technologies based on Josephs and junctions, where you have two superconductors which are separated by an insulating material, and then you have a supercurrent that goes through this system. That's a super Josephson effect. And using these quids or these sort of circuits, you can kind of build superconducting qubit technologies. Then we have semiconducting qubits. I'll talk a little bit about it a little later. And then we have photonics. That is, how can I store information in the state of a photon, in the polarization, or in the orbital angular momentum and stuff like this. This is the heart of it. Now, next, this doesn't work. Okay. This is it's a multidisciplinary research because at the heart is quantum physical laws and experiments, right? Going back to photoelectric effect that you might have seen, right? And what do you think about this this quantum effect when you think about, talking from high school? Audience, can you think about what is something about, this physics part and quantum, why it excites? All of us have done our high school, though we have gone into different walks of things. I'm getting back to high school, 10th grade. So you have a particle behaving like a wave and a wave behaving like a particle. You might have heard from your high school teachers in physics. This is the heart of it. Indeterminism, uncertainty, right? Then superposition, entanglement, all of these features are part of these quantum effects, and that's the underlying physical laws. Okay? From these physical laws and compliant with these physical laws, we have to build systems. So where do we start? Maybe we start at this side. You have quantum devices. Maybe think about superconducting circuits and things like this, or semiconducting qubits and stuff. And quantum computing algorithms, quantum information processing, which is going to be communications and all of this, information theory, communications and metrology and all that, and quantum circuits and systems, right? When you wrap them around, and then it becomes quantum technology. And when you embrace quantum technology, it's a quantum integrated system. So a lot of it is 99% classical still, but there is 1% quantum, which is at the heart of all of this. Okay? So this should give you a sort of an idea that it's a multidisciplinary approach. You have physicists, you have mathematicians, you have engineers, and all of them working in tandem to get these things done. Of course, when everything is bundled and packaged and going great, you need industrialists to kind of take it to the next level, and it seems seamless. Right? Today AI, just as the way AI has pervaded, you don't have to type anything. As you're typing a few keywords, automatically it suggests what next, right? And this is something which researchers have done 20, 25, 30 years back. Now we are at the same stage in quantum, 1950s and 1960s kind of setup, where we are kind of at that stage of computing, and we want to take it to deeper levels. So, this is the way I see, okay, fine. I thought it may have a sensor there, so I have to sense myself here, no worries. So here is an example, I think, for those of you in the engineering side to see what we are talking about, these qubits. And here is, the work by Jason Peta and others, and that's published in Science in 2005. So they were able to isolate and measure 2 electrons, and here you have these. So basically, we have these gate-defined quantum dots that was fabricated using these heterostructures with molecular beam epitaxy and electron gas at 100 nanometers below the surface. So you have this left and the right side of these patterned wells, and by applying negative voltages, it gives rise to this double well potential in this form, and then you have a voltage controlled tunnel barriers that connect these reservoirs. Right? It's like from the reservoirs I can send these electrons into this or that, and I can also adjust the detuning potential between this and the potential difference between this right and the left, and I can have this interdot coupling. So effectively I'm looking at a single electron moving from one dot to the other, or 2 electrons moving from this dot to the other, and stuff like this. And these type of things I want to control and manipulate in the form of arrays. Huge arrays, and that's the heart of semiconducting qubits or even qubits. Okay, So like in the case of the quantum computing paradigm that you can think of, you can work with non-binary states. In the case of the classical paradigm, you think in terms of binary, right? Everything is now, if I write, I'm typing a text, it is all converted into some coded symbols, and finally it's going to be zeros and ones. That's going to be working with base level, whether you're storing it on a hard disk drive or whether you're dealing with communications, it's finally that. Unless it is a non-binary for whatever it is. But quantum, you can do non-binary states. Okay, and that's a power, and that you can harness. So this is a sort of, those of you who are interested in VLSI and this fabrication and things like this, be mindful that you may be getting towards these type of areas. This is where you even think of designing these pattern gates and stuff like this. And now it's just not one particular coupling between these two left and the right reservoirs, but you have to have an array of these, and then you're going to do computation from there. Okay, so this is at the physical level. Yeah, I have to remember, this is a part of the memory, right? So quantum basics. So what is this quantum bit, right? So people are used to tossing this coin, right? Coin toss, right? When do you do this coin toss? Maybe cricket. You have to decide who has to go first, bat first, right? So when I do a coin toss, right? When I'm flipping this coin in the air, do you know it is head or tail? You do not know, right? It is in superposition. It can be head or tail or whatnot. It is spinning up in the air and that's it. But when it falls on the ground, clearly somebody said, oh, it could be head or tail, the probability half. It's assuming it's an unbiased coin that I am flipping. Right? If both sides are head, it's a different thing. But head, tail, on either of the faces, you flip the coin up, it spins in the air. In the air, it is in superposition. It can be head or tail, you do not know. There's the same state with the quantum bit. Classical bits are precisely 0, precisely 1, because they are not quantum states, right? It's a voltage you measure from your CMOS cell, and you can figure out anything beyond this is one, digital 1, or which is not above a threshold, it is digital 0. But quantum bits are different, so they are in the superposition, and n-level quantum states reside in a 2 power n dimensional Hilbert space, and then when you measure, you irreversibly destroy the states. So measurements is the action of this coin which was tossing up, which fell on the ground, and that's it. And when you see it, either it's a head or a tail, that's a measurement. Okay? So it's like, how do I put it? You have a veil, inside the veil you have a lot of computation that is happening. The moment you remove the veil, it just collapses to whatever you see in the register, right? And the power is behind the veil. Alright, so all the mathematical action can be described in terms of unitary matrices and these mappings. So this is a kind of a picture of how a qubit can be, one single qubit can be on the block sphere, and of course the visualization of this geometry in higher dimensions is going to be hard. Right. So DiVincenzo had a criteria for universal quantum computation, and I list some of these. So please feel free to stop and pause and ask me questions. Okay. So now we are one step deep down. So we understood what a qubit is, right? Qubit is not like a normal bit, it is in superposition, right? So we'll talk about various aspects of these qubits. So qubits, these must be well characterized for scalability. It is, and most of these qubits can be noisy, and that's the reason why we need powerful error correction codes that work with these systems. And we should have the ability to initialize the state of the qubits to a simple fiducial one, that is a reference state, for example, in tensor product of all of these ground states. The qubits should have long decoherence time. Decoherence is when the qubit has to be, when do you think you won't have any noise? We have noise, right? In the room we have noise, interference. I'm hearing some music also somewhere in the behind. So there's noise, there's interference and everything else. But for qubits, when they couple to the environment, they decohere. Decohere means they lose their state. They're coupled because it's an open system. So when you couple the qubit to the environment, it decoheres. And we want to have decoherence times which are large than the gate computation times, because this is where you can unleash the power of quantum computation. Okay, so this is where your Rabi oscillations set up, and then you kind of lose these, it decoheres. So all your computation should be done within this decoherence time, so there should be several orders more than the gate operations, time for gate operations. Okay, so single qubit operations you can do when you have two qubits, they can be coupled. And coupling of these two qubits is the heart of entanglement. It's very interesting. That means I have a photon here, I have a photon on moon, they're entangled, and whatever is happening here is the same action there that reflects. It's like, it's a spooky action at a distance. So now, having understood these details, then what we need is a universal set of gates that we can realize. And what do you think is universal for classical gates? Huh? Digital circuits, please open up your mouth. Basic gates, but you can realize universal, that you say is universal, and or invert not, right? So like this, you have basic set of gates, but there's a little more to that. Okay, you need a universal set of gates to realize quantum gates. Qubit specific measurement capability, that is, you need to have readout circuits that is feasible. And for quantum communication purposes, we also need the following: interconversion from stationary states to flying qubits. Photons are flying qubits because they are in air. They can be in space. Photons. Stationary qubits are the superconducting qubits or semiconducting qubits or quantum dots, what we say, that are there for the purposes of computing. But computing and communications are interrelated. Okay, if you are you're working with your bank, sitting on the mobile phone, there is something in the air, something here, right? There's computing, there is communication, both happening. And the same thing needs to be done for quantum communications too, and that too securely. Next, ability to communicate flying qubits across locations. People are now talking about satellites that are connected to ground stations, and how you can unleash this power of quantum communications using entanglement, that you can get better throughputs than what you can get classically. So this is the heart of all of these things. So now what we do is we go one step further. So this is a little beyond. All right. So let's go further down, try to build the story. So what we are trying to do is to realize the power of universal quantum computing. We need to, if you have a cell, that will be great to connect this. So to realize the power of universal quantum computing, we need a set of gates. One is a Clifford set of gates, and then this non-Clifford set of gates, and that drives universal quantum computing. And Clifford gates are those that they take Pauli operators to operators via this conjugacy constraint. And the Clifford generators for a qubit include this C0, the Hadamard gate, and the yes gate. But Clifford operators are not universal set of quantum gates, and there are a set of other gates called non-Clifford gates. And some of these non-Clifford gates are like this T gate, which is given by this 2x2 matrix, which is on the diagonal it is 1 and e power I pi by 4, which is called a pi by 8 gate. And these cannot be approximated by a finite set of operators in the Clifford set, and therefore it motivates to generate these non-Clifford gates. So, and then non-Clifford gates can be realized using Clifford gates and special states called magic states. And the heart of this is, and therefore to get these magic states from noisy versions is the heart of magic state distillation, and this is what I'm going to talk about a little bit. So examples of these non-Clifford operations include rotational gates and things that are used in quantum neural nets and stuff. So Bravi and Kitaev from Caltech, in the paper published in Physical Review A in 2005, they showed how magic state distillation can be at least accomplished that leads into universal set of gates. But what was missing in their work, what was missing in their work is the role of these codes, error correction codes or stabilizer codes that can actually do this magic state distillation. And this is where we took up this problem, and we have a complete theory for magic state distillation along with efficient circuits that can do that, plus also fault tolerant computing, and that's what I'm going to talk about it a little bit. So how many of you in this audience are comfortable with a little bit of math and algebra to deal with this? Or so I can code my talk accordingly, I can go superficially or I can go deep. How do you prefer? It's adaptive. Superficial? Okay, fine. I'll go superficially. So this Hadamard gate is this gate. And do you recall, for those in ECS, do you realize how this 1, 1, 1, minus 1 matrix is? This is basically from your DFT. You do the fast Fourier transform on a 2 by 2 or a 2-point DFT, you'll end up with a DFT matrix of this form, and that's a Hadamard gate for a qubit. So this is the Hadamard gate, this is the S gate and the C naught gate, and the T gate, which is the non-Clifford gate, is basically the square root of the S gate. So, and to realize these type of gates is where we work with magic state distillation. I have tough time with this, and all right. So what is this magic state distillation? So let me motivate how you can realize a T gate. So this quantum state is basically this state which is a superposition of this 0 and 1 state. And then I have a magic state which is basically this T state. So what I want is I want a gate operation on this qubit. Okay? So this qubit is in a superposition of 0 and 1, and then I want to take the gate action of this to realize that. So at the preparation stage, I basically, I have this the state psi, and I have this magic state. At the preparation stage, I have this. Then I have a control gate operation that I do, and then I do measurements, and then I feed this measurement back into this to the S state, which is basically Clifford, and then I can realize the action of the T gate on this state psi. Okay. Now, how do we get these T states in the first place? Because I will have noisy versions of these states, and the heart of magic state distillation lies in this. So, if you see this magic state injection circuit to realize a T gate action, so you have a preparation stage, you have a control gate operation, and then you have measurements and feedback, and then you send the classical output post measurements to this S gate, and then the action that you have on the state psi is the T action by discarding a certain phase. So can we go one next? So what I did is a little bit of math. How many of you in the audience are comfortable with any of this math? None? Skip. Okay, I'll give skip 2 slides if you want. Okay, and so what we have is by ignoring the global phase, by doing these actions with preparation, control gate, and measurements and feedback, you can kind of realize the T gate action. So if you want to know deep down math of all of this, you should do a quantum computing course at IESC. Okay, and Times Pro is also offering these courses for professionals, and I'm coordinating this. So if you want to learn something about quantum computing and stuff, I think you have to enroll into this to learn more. Okay, so next. So it's like a small cartoon here for universal quantum computing. That means you have this distillation. Somebody is, from noisy versions of these quantum states, you have these magic states that you distill. That's a Druidics, and he's giving you all these T states, and now you use these T states, and then using Clifford operations and magic state injection circuit, you realize a non-Clifford operation. Now with non-Clifford operations, non-Clifford gates and the Clifford gates, you have a universal set of gates that you can do quantum computing peacefully. Okay? With Clifford itself you cannot realize this. So now where we came is, next slide, is to do magic state distillation. So now any quantum state over a p-level qubit can be expressed using p square minus 1 Heisenberg veil operators, and then what we do is we do the twirling action by doing dimensionality reduction by projecting this quantum state sigma onto the hyperplane spanned by the eigenstates of the operator u. So we just start with a operator u, and the magic state happens to be one of the eigenstates of this operator u, and then what we do is first we do dimensionality reduction by by doing twirling action. Next. So then what we do is we further simplify this. Then we take n copies of this state, because this is where this error correction comes into play. So what is the heart of error correction for all of you? Simplest way that you think of error correction? Huh? Having code, even simpler, very simple. Repetition, right? Your friend or your teacher tells you 3 times the same thing. You don't understand once more, again once more, 3 times, 4 times, 5 times. It is told, it registers in the head. Okay? So that's the simplest. Its repetition code is not good. But of course you can do much more efficiently with error correction. So this is where the stabilizer codes or the quantum codes play a role. So you make n copies of this noisy twirled state, and then you try to distill the required eigenstate using this stabilizer code. Okay? But the next question is, how can we even build stabilizer codes? That's the next question. Yeah. So not all the stabilizer codes can distill magic states. The choice of a stabilizer code for a magic state depends on the alignment of the noisy state with the logical state spanning the stabilizer code. Right? Logical operators are nothing but the encoding operators or the code words. Okay. So now you have to have this magic state that aligns with the logical state that spans the subspace of this stabilizer code. So what we do is we consider a p-level stabilizer code, n comma 1 comma d is the distance, and n is the physical qubits, and 1 is the dimension of the code with associated stabilizer generators. So stabilizer generators are those generators that are minimally required, that you can kind of span you can construct all the stabilizers of this code, right? So it's like you understand a parity check matrix, right? And you look at all the linear combinations of the code word. The linear combinations gives you another code word, and that is the kind of equivalent isomorphism between that and in the operator theoretic realm that you require for quantum. Because in quantum everything is you measure and you infer. Because if you poke into the state, it collapses. Right? You don't collapse. You bring in an ancilla, you kind of measure that somewhere here, and then that is the action of the error correction. Okay? So it's like, how do I put it? Sorry, please, there's noise here. See, in the case of, so this is where I think this precision of measurements comes into play. So I give you, I don't know, a texture of you touch your skin, you feel it is good, or maybe if the skin is bruised or something, a doctor feels it, or you feel something is wrong, or you touch the texture of maybe fine cloth versus wood, you feel immediately, you get a texture, right? So what is happening is you're doing some measurement. This is your sensor, this is your measurement, and when you do the measurement, your brain works and you figure out what is the objective there. In quantum, any measurement destructs. The moment you make it interact with photons or whatever it is going to destroy. So you don't want to destroy the state. So how do? You make the projections. What's one way? For example, here, if I want to figure out what type of material this is, I shine light, I get the reflectivities. From the reflectivities, I assess what is the state. From the scattering coefficients, I can figure out what is happening there. Correct? But in quantum, even that is an interaction. So therefore, I have to bring in ancillary qubits. That is, I don't directly poke the quantum state. I figure out by somehow coupling this state to the ancillary state in the Hilbert space. On the ancilla, I figure out the projections from my measurements. And then I discard the ancilla and I can figure out what is happening, and I infer the errors and I can pull this out. Okay, so next. So you have to alert me how many minutes, because I can go on. Another 10 minutes I have. Okay. So this is the geometry of this magic state distillation. So this green, my green is yellow on your slide. There it is green and blue. Somehow the colors are completely distorted on the screen here. I don't know, for whatever reason. So the green simplex is spanned by these states phi1, phi2, phi3, and the blue simplex is spanned by these states xi's, representing the code. This is the code space, and that is 3 power n dimensional qubit state, which is the input to the magic state distillation. And this intersection in orange on this, where the two simplexes intersect, is where distillable states lie. So if you're inside that intersection, then you can distill the quantum, the magic state. Otherwise you cannot. And now from the noisy states that you prepare, you want to distill that quantum, that T state or whatever those magic states are, so that you can realize non-Clifford. So that picture should be clear next. So there are 3 important steps. First, we prepare the state, which is an input to this magic state distillation protocol. This can be expressed in terms of these eigenstates, a lot of math here. So, and what we do is all stabilizer generators of the code are measured and post-selected in the +1 measurement outcome, and then you project the state back, and this Clifford operator D, which is a decoder, is applied to the projected state, and it sends the logical operators of the code to a single qubit operator, and this single qubit operator is basically what the state that you want. Okay, so this is the heart of it. Next slide. So now what we did is we did a bunch of math to do all of this, come up with simplifications, and we took this noisy projected state, and then with some simplifications we were able to express this in this form. And we said the condition for magic state distillation is that the output of the protocol, you want to do the probability P naught upon the total probability Ps of the state phi 0, because this is the state that we want to distill, should be proportional to xi 0, which is the initial, which is not equal to 0, and this should be greater than the initial syndrome probability. So you start with noisy states, and you keep doing this iteratively. Okay, you project it onto the error correction code, get the measurements, then you have a post measured state, you get again 10 copies. So the noise keeps on, you distill the noise. You keep on reducing the noise to a certain extent that is within the threshold, and once you're within the threshold, boom, you're able to correct everything up, and you get that state. Okay, next. So there is a threshold for this magic state distillation that's interesting, and this the threshold is the point beyond which the MST protocol cannot purify the state. This is like the code threshold that we have in error correction, right? If the channel is very noisy, a good example, this is a classroom, everybody is talking, I don't have the speaker, and my voice is feeble, I cannot transmit information to someone who's sitting at the end, right? Because the noise is so much that it overwhelms the information. The same thing for magic state in this distillation protocol. So if you are within a certain threshold of the noise, you can distill the state. Otherwise, you cannot distill the state. And we are interested in those threshold points. Okay. So this is based on these key equations, which seem horribly complex. You can compute the and based on the fidelity functions, you can compute the noise threshold analytically. So we have a formula analytically that you can compute these noise thresholds. Next. And it makes sense because we are interested in the evaluation of the fidelity functions over the state xi 0, which is this is the state that we want to distill, this magic state, and the code parameters are now buried within this code projection operator P that we have control over. Okay, so we have now an error correction code, it is a stabilizer code, quantum stabilizer code that is used to take these noisy versions of the quantum states and then distill the state that we are interested in. Next. So these magic states are basically pure states, and you could go. So if this is like this is a geometric feel of this magic state distillation process. So the state rho lies in the post twirling, it lies on the plane and you can vary the parameter delta, and you can have this linear combination, and you can confine it to the line. And the red regions are the distillable regions, or if you're within this region inside the cone, you can you can get the noise and align it onto these states, H plus and H minus. Okay, so and one can kind of think about codes, error correction quantum stabilizer codes that can give you distillable states. Next. So why is this magic state distillation process working? So we had an information theoretic field for this. So using quantum entropic arguments, and we proved that this magic state distillation process is a converging process in terms of the quantum entropy. So when you are with pure states, the entropy is zero, okay, because there is no uncertainty in that. So therefore, you kind of go these states to align to the pure states where the entropy is zero. So you start with something that is mixed, with this high entropy, and then post this purification, this distillation process, you kind of align to the states, the pure states. Okay, so this is I think is a nice theorem that was established from quantum information theoretic perspective, which was actually missing in Bravi's work. So I think we have extended all of these to this. So and we simulated this, and over iterations we saw that it was we saw this convergence, right? This is non-converging here, and this is converging because diving down to zero in terms of quantum entropy. Next. So somehow the resolution is a little off between what I see on that and what I see here. I don't know why. This display device possibly. So all right. So every iteration of the magic state distillation process converges towards a pure state as long as we are in the threshold and is in the quantum entropic sense. And the second theorem is the MST procedure operates below the noise threshold to perform purification. The probability of projection keeps on increasing. At every step you're better and better and better, right? And that's how this distillation process works. Next. These are some simulations to show the convergence of the magic state distillation process and how we can distill, these H plus minus states using the 5Q code. Next. So the question now we had was, okay, fine. Some people have taken this LMPC code, 5-qubit quantum code, and distilled some states. But can we do something better? So is there something that we could do more? And the answer is yes. There is a scaling that you can increase the length of the code. You can also increase the distance of the code, and using these two parameters, you can essentially improve the thresholds, noise thresholds. Okay, so it's not just I take some code and I don't know. So first we answered 2-3 main questions. Can you distill can all stabilizer codes distill magic states? No. We provided conditions for the distillability of magic states using stabilizer codes. Then we showed how we can use the stabilizer codes, that there's an art of constructing the stabilizer codes for magic state distillation, and the threshold scales with length and the minimum distance. So we proved these results, and these are some analytical results. So for example, we exactly show how much we have to improve distance from D1 to D2 for the same length for a 1% improvement in the threshold. So all of this is all practical. Okay, it's just the theorems in the math we do has a recipe that lends itself into algorithms that you can actually work with. Next. So we then looked into this 13-qubit code. Qtrit is not a qubit but qtrit in 3 levels, 0, 1, 2. Okay, can you imagine in that sense? So we were able to distill these yes states, and so we use a classical ternary this code, 1377 code with these parameters, and this is a self-dual code, and using this we can distill this state. But the threshold may be less, and we went to higher code lengths and physical qtrits, and we were able to get very close to those thresholds. Next. So what we do is we construct the quantum code using the CSS framework. This is the Calderbank, Steen, Shore framework, and using this we construct this 13,1,7 quantum CSS code, and from this we derive the logical operators of the code. Next. and then we do twirling, you do the state preparation, and then you construct the code projection operator because we know the code essentially, and then we project the noisy states onto the code space of this quantum code using this code projection operator, and then from which you get this state. This is a 13-qubit state. And next slide, please. So what we do is we decode the code word because it's a noisy code word. We decode that using this decoding operator. We discard the ancillary because only single qubit that we need to get, right? We discard the rest of the ancillary states, distill the state that we are interested in, and then we kind of iteratively go through this map to until convergence. Next. So some of the results here that we had is the state of the art codes were these 513 and 1113 for these magic states, and we were able to push these thresholds to near the limits of 0.5 and 0.75. And the theoretical threshold, these limits, they are obtained by computing certain phase point operators or these Wigner functions on these quantum states, and those are the limits that you could achieve. And we could, using these codes with, as you see, the lengths or larger, distances or more, we are able to get to as close to threshold as possible. Okay, so there is theory, there is practice that are coming together. Next. So we also, for those, okay, fine, you're interested in a circuit, yes, we have a complete decoding circuit. We have outlined, so you have to be familiar with quantum gates and things to do this, right? So I just gave a snapshot of this, and the above circuit is based on the code proposed by Shiroman Prakash, that has a threshold of 0.38, but we are near 0.71, and I can't list a huge circuit there, but we have a recipe to do how to get that. So we have all those details, and you can, and for those of you who are interested in building these circuits, you can look into the work by my former PhD student Priya Nadkarni, and we have published this paper in T Transactions, Quantum Engineering, in IEEE Transactions, and this other paper by Sharma and myself in Physical Review A. Next. So not only this, we have error propagation. I just have 2 slides, I'll be done. So quantum noise is manifest in 2 ways. One is phenomenological noise, which is because of the channel itself. The other is gate noise. Gates themselves can be faulty, and error propagation is a key thing in these things. So now if you don't want to have error propagation, so what we did is recently so this is how, for example, the error propagation of an X error to the target, this is depending upon the control here, you can, this is a target essentially. So now I can have this where the propagation of X error happens to the target when the control is affected by, this is a control which is affected by an X error. And similarly, you have error propagation of the Z error essentially that propagates to the control qubit when the target is affected by the Z error. So you have these during control operations, you can have propagations of these errors. These are the equivalent equivalences. Next slide. So how to do fault tolerant computing? There are 2 ways. One, every gate that is faulty, you bring in an error correction code on top of it. Every gate you protect it through an ECC, and that leads into a swelling of gates at every stage. And this is the concatenated scheme that was proposed by Gottesman in 2009. So what we did is we overcome all these issues by proposing entanglement assisted transversal architectures that this is a recent work, 2024, that was published in APCIT Symposium of Information Theory. We have a fault tolerant circuit which can accomplish the same with drastically reduced circuit gate complexity. Okay, and we're able to limit error propagation. Next. So we are almost towards the end, I think. Next slide. To summarize, quantum error correction is very important. Okay, quantum error correction over qubits are a powerful generalization. That's the reason why I talked about qubit codes, not necessarily qubit codes. When you are in higher dimensions or higher fields, you have that much of power to work with, and then is very powerful to realize not just applications in quantum communications and fault-tolerant computing, but also towards magic state distillation, which is required to do to realize universal quantum computing, because you need both Clifford as well as non-Clifford gates. And this talk that I outlined talks about that part where you can realize universal quantum gates. Okay, Clifford is no big deal. We have proposed efficient circuits. You can refer to our papers that for realizing efficient encoding circuits. But when you want to realize non-Clifford operations that is required in quantum machine learning applications, then you would read magic state injection circuits that requires magic states. And the heart of that lies in the theory and the results that I proposed here. Okay. Now, I think this is interdisciplinary. Who said you are physics, you are electrical engineering, you are computer science, you are math, you require all of it. It's all the heart of math, physics, and WCS. Okay, this is interdisciplinary. And a few takeaways to remember: magic state dissipation converges in the quantum entropic sense when we are within a threshold. Noise threshold depends on the distance as well as the physical number of qubits. Okay, the absolute physical limits on the threshold are dictated by the discrete Wigner function, which is basically is a quasi probability distribution acting on this phase. That is induced because of this phase point operators. Okay, and then we also have decoding circuits of the stabilizer code, which is used for the magic state distillation. That's also the practical part of it, and we know we have complete control how to do this. Okay, end to end. And the other takeaway that you have to know is you can think of entanglement assisted schemes to realize transversal architectures for fault tolerant encoders that limits the probability of error propagation. So given a certain probability of error propagation, I can always give you an error correction code along with its parameters and the entangled qubits, etc., that you would want to realize that. Okay, so that's detailed in a nutshell. So this is a fun problem. This is more efficient one than what Gottesman proposed in the concatenated scheme. We have communicated our results, recently that we published in APCIT, and then of course the longer version for journal and stuff. So it's all fun stuff, interesting stuff, and things. The reason this is a take home beyond the technical part that I would like to project is my student Abhi Sharma. He is a direct PhD student. He started with a bachelor's just 2.5 years back, maybe 3 years back. He was from ECE background, from a college in Mathura, had no idea about quantum, nothing. And today I feel so happy to see this student has 3 conference publications that he published: International Conference on Communications, International Symposium on Information Theory, and another paper that he has communicated at the Information Theory workshop and stuff, along with 2 journal papers. So I think it's a success story from, if I were to put it from a quote unquote human factor. Okay, so problems are fun, it's challenging, and this, and when you work and you have all the results, you see theory and practice are connected intricately. Okay, it's not like theory that you do because it's just there. You want to write some theorems in Greek and Latin and confuse the audience or something. It's not that. So from the juice of the theory, you have the practical part, and when you see it implemented, that's great. I mean, you have a proof of concept. Now to realize those gates, etc., you need fabrication. Okay, you have to think about how building the squids. This can be done. That requires fabrication. That's all your nano quantum / fabrication part. Okay, so end to end you can realize quantum computing. Okay, it's not something which is a fantasy or something, it's reality. So I think this should motivate some of the young minds that if you love math and doing all of this, I think it's fun to be in this area. And people say, oh no, I do engineering, I forget math, or I do math, I don't know connections to engineering. So my group, my lab has people in math, people in physics, people in electrical engineering and computer science. So all the people. So it's fun to work, and we talk. Initially the language is a little different from different spheres and from different zones. Spheres I would call them, whatever in your disciplines. But after a year we talk the same language. All of us know what we are talking about. Okay. So I think that completes my talk. I hope I was able to inspire you that it's a deep work, right, that I don't know how much you are able to garner and fathom into, but hopefully you've gotten the gist that this talk covers how we can do universal quantum computation. That's it. Thank you. Questions? Please feel free to ask questions. Any questions? None? You should have questions. You don't have questions, that means two things. You understood everything, you have not understood anything, or it is hazy. Of course it is hazy because you are seeing all the equations and you are feeling like, what is this magic state? Why did you call it magic state? That may be something which is bulbing in your head, right? Or things, or feel free to ask anything. At least I'll pinpoint you some resources that you read. Because it's all deep work at the heart of physics and math. Yeah.
Join this.
That's coupling. Okay. So you couple. So I told you for example I told you about those quantum reservoirs, right? This state and this left and the right, and then I can the conductance can be controlled by and you can do this interdot coupling. Fields. In IAC, we are building this. We have this part of this National Quantum Mission. At least I know for sure you could not the complete structure for the semiconducting qubits. At least I'm part of that initiative with one of my colleagues there. Yeah. So qubit is a state, right? Qubit is a state. So let's say in terms of energy levels, if you think of, right, it's a ground state, and from your basic physics, right, ground state and excited state is a certain energy level. That it is a zero state, this can be one state, and you can kind of think about it that, right? So, or if you think about the polarization, right, it is a left plus right polarized, sort of a combination of that, with maybe an e power I theta sort of phasor that you can kind of connect these two things. And once you understand the physical states, the Ket-Bra notation that you have, that you can express, these are just vectors in a complex dimension, complex Hilbert space. Yeah. Clear? Okay. The coupling is how you bring in two systems, gange them together, and that's where the states can become entangled, and then the fun begins. It's like, how do I say, these are not two separate entities. You have a field which will bring them together. Okay? And there are correlations across. That's coupling. Good example is, your RC coupled amplifiers, right? That coupling is, if you have two BJTs, then you can have a coupling, right? And if you bring in feedbacks and things, it's coupling. That's all classical, but here now we are at quantum. Small states, yeah. Questions? Should have questions. I think something or the other. It's drab otherwise. Or it was boring? How many felt it was boring? Just raise your hand. I hope it was not boring. Yeah. Because these keynotes are meant to be at the high level, but of course I went into certain detail to show you the how deep one could go in and what you could do, right? And I wanted you to get that feel of research so that you can be enthused about doing things. Otherwise my talk would be very, very high level without any equations. I asked Patil, does he want any equations or not? So if he had told me no equations are required, then I would present my talk completely without any equations. I could do that next time. Or maybe just one or two. Anything else? Okay.
Thank you so much, sir. Your words have truly resonated with us and provided valuable perspectives. We are deeply grateful for the time and effort you took to share your knowledge and experience. Has added immense value to this conference. On behalf of the organizing committee and everyone present here, we would like to extend our heartfelt thanks to you, sir. Thank you so much, sir. We will break for 5 minutes and continue with the next keynote address by our chief guest, Mr. Robin Verma. I request you all to kindly keep your mobile phones either in silent mode or you can just switch off. Kind request to all of you to either keep your mobile phones in silent mode or you can just switch off your mobile phones. A very good afternoon to one and all present here. It is our great honor to have with us Mr. Robin Verma, Vice President, Commercial Banking, Wells Fargo, Hyderabad, as our keynote speaker. He is known for his remarkable contributions and groundbreaking work. With a wealth of experience and passion, he has inspired many of them. May I now request our chief guest and the keynote speaker, Mr. Robin Verma, to take over.
Of the day I'm struggling with the mic. So earlier I was just thinking this is off.
Yes, sir.
Yeah, okay. So it's better? Right. Oh, I can use that. Do I have to put it that side or this side? This side also? Alright. Again, I'm in front of you guys. I think many new faces from my previous address note. I mean, not address note, the address which I have done in the starting of this conference. So I got to know most of the students right now. Majority are from MBA. Some are from the engineering background, sitting over there in the audience. Thank you very much, everyone. I'm super excited to see you all. The floor is packed and I appreciate to come over here. So about me, as you have already heard about my introduction, I am from a data and analytics background. I worked it's almost like 2 decades. I have been working in the data and analytics. I have done a lot of data engineering projects. I have changed and lived the entire era, how the data has been grown, has moved from the databases to warehouses, to lake houses, and now to the data mesh. So a lot of changes have happened in the industry. And that's why I have chosen the topic, the importance of data in the AI and the Gen AI world. And what we will do is that we will have we'll cover the slides, whatever I have, and then in the end we will open the floor for all of you guys. Okay. So, as you already know that data is very much indispensable in any field. You need data for anything. Whether you are researchers, you are engineers, any normal person, or even a bookkeeper, a shopkeeper, they are maintaining the data for getting insights out of that. That's the beauty of the data. And the astounding fact which I tell you is that the total amount of data created globally reached 64.2 terabytes or zettabytes in 2020, and over the next 5 years it's projected to grow over 181 zettabytes, and that is a massive explosion in the data. And as you all know, data is the backbone of the AI. If you see the statistics, according to the latest estimates, 402.74 million terabytes of data are created each day. Around 147 zettabytes of data will be generated this year. And as I mentioned, that by 2025, it's been a 181 zettabytes. So how we are going to make a sense out of this data? Every organization have data, but they don't know what to do with that. Still, in the current world, very minimal amount of data is actually being used to get insights out of that, which help organizations to make timely decisions and capturing the market, creating out the new products, and as well as doing a cross-selling, looking at what customer wants in the today's world. So I have some statistics for you. Is if you see here in the lower bar graph, how I can do a red pointing on this one? Okay. So this one, if you see the global data generated annually, look at the explosion in the data growth. And I think after 2020, it suddenly rised up. And if you see in this data created growth projections, if you see the highlighted one, the red part, it is estimated that 90% of the world's data was generated in the last 2 years alone. And majority of this data is coming through the videos. A lot of Instagrams, TikToks, social media profiles, social media uploading, all this data is majorly a videos data. Rest all is coming from the other sources like internet, webs, source systems of the banking domains, source system of the healthcare, sensory data, images, everything else is there, but the video is the main contributor. And as I mentioned, the zettabytes, I just put how the data bytes have evolved with time. We started with bytes, then kilobytes, then megabytes, and now we already reached the zettabytes. And you can see like what are the next versions of the measuring the data volumes. So this is about the importance of data, which I wanted to start with, like how exponentially it is growing. As you might have heard the term very frequently in the social media, data is the new oil. Like oil have to be filtered to be useful, similarly data has to be filtered, created in a structured way, which should be understandable by the normal human being to make some decisions out of that. And that is why, if you see here, data is not useful or not valuable until it is refined and processed. So data is often called the fuel and blood life of AI. Why? Because all the AI models which people are working in today's life, they are totally based out of the data they have trained on. If the data is not clear, not clean, and not enough also, you might not be able to give the right judgment. So it's very important to know the data and make it in a structured way. What is the impact on the performance? The quality and the quantity of data directly impact the performance of AI models, right? If, for example, like you probably have heard the term ethical bias in AI, right? What that means actually? It means, for example, if I'm going to train my AI model with just one ethnicity and their ideas, their suggestions, it will be always a biased when it will give the results. And that is not what we want. That is something people are afraid of. So that's where the more the data we will be getting to work on, to train our AI models, the more correct actual decisions we can get out of them. So here I'm going to talk about the data growth and the changes in the storages. So as we discussed, like, the sources of data could be social media posts, that online transactions, the sensory data from the different IoT systems, and much more, right? So it's never ending kind of thing. And in fact, even in the responses we are trying to generate from ChatGPT, we are giving it the prompts over there. A lot of prompt engineering jobs are upcoming in the market because that is the need of the hour, because we need a right prompt engineers to train these chat GPT models, and that data which is generating out of it, because they are also learning, and that is also contributing to the data. So this rapid growth actually bring both challenge and the opportunity, and especially the unprecedented opportunity in the AI. So I have lived this whole era where the data storage systems have changed. In the 1980s, data warehouses were there, where regular structured data people used to get. They do the ETL transformation out of it. Does anybody know in this room what does ETL means? So ETL means it's a part of data engineering. So every organization in the world, they have the data department. Their work is, whether it's any product-based company or whether it's a service provider company, any domain sector, banking, healthcare, retail, or any other thing, right? Everyone have a data department. What they do is they have the data engineering teams over there. They have a business teams, they have a data engineering teams. Business tells technology, which is data engineering teams, okay? It's like a two departments, like business department and technology department. So as I'm a part of technology department, so business will come to me and tell me, hey, I want some data to be uploaded, onboarded in our system so that we can get more insights out of that, which can help us in decision makings. So that which can help in creating the future products as per the demands of the customers, so that we can capture the market, right? So they will come to us. We as a data engineers will say, okay, give me a source. Which all sources you want to bring in-house? They will tell us the source systems. Source systems could be any onboarding system, which is the front-end system in the banking, front-end people who are working in the banks. It could be the online web applications. It could be a point of sale system where we are doing transactions. All the data for the payments, they are coming out of that. We are processing that data. Or any third-party data, the benchmarking data. There are companies in the world who will tell you, hey, this is your competitor. They are using the similar products, where you stand in regards to them. So that kind of data also we process to get the insights out of that. But the problem here is, when this data comes, it might be having a lot of anomalies in that data. Data might not be complete. There are certain missing elements out there, and so many missing information. So to make that data meaningful, this ETL process means extracting the data. T means transform, and L means loading into the data warehouse, which is the database. Okay, so this structured data, when in the 1980s, data warehouses are the real thing where all the data of the organizations get stored. It used to contain all the history of the data for every customer, how many transactions they are doing. Even if I am doing like 100 transactions per day, this warehouse will capture and keep those data for historical purposes. And then on top of that, this Power BI and reporting, which are the different tools to take the insights and take out the reports out of that, they run on that, on top of that, and they actually generate the reports for the executives, for the business teams, to take the insights and to make a go forward strategy. Okay, and how it evolved is like in data warehouse. When I joined in 2004, my first company, then that's where the data warehouse concept still was there. But then the demands changed, industry needs changed. There are companies like Facebook, Google, right? They don't have always a structured data. They have semi-structured and unstructured data, which means like your social media posts, your videos you're uploading. They have no format, like in terms of storing in a database, in the regular database, because regular database are these ones which are there in the warehouses. So that's where the concept introduced data lakes, which are our big data lakes. You probably have heard about Hadoop, Hive, those technologies, big data. So anything in its raw format can be loaded into the data lakes. Okay, it don't have to have any structure. And later on, once the data is over here, again we can perform the same ETL process, and we can clean the data, make it readable, and put it in the data warehouse for Power BI reportings, for the data science and machine learning. So when the data lakes were introduced, suddenly machine learning and AI ML became so popular because what was the need of the data lakes is these machine learning models, deep learning models, they want raw data to get the predictive and prescriptive analytics out of that. Okay. Now, the next era came in 2020 was the lake house. What exactly that means? It's a combination of the warehouses and the lake house. So they mentioned like, okay, why we need two different identities to store the data? Why can't we do it in a single one platform? And that's where the data lake house concept came into the picture, which contains all the relational as well as the semi-structured, unstructured data. And then in the 2021, the data mesh came into picture. That's another terminology. So and data mesh, what it exactly do is, it keeps the data domain wise. Like say within the banking, you have the transactional data, non-transactional data, data related to real estate, data related to financial equipment, data related to lending platforms. So all these will be segregated domain wise, and then on top of that, data machine and machine learning algorithms, analytical reporting can be performed. So in an industry, both the business and the tech teams, they work in coordination next to each other, shoulder to shoulder, because business gives the work what tech have to do, achieve. So basically, and then tech gets all that tech expertise, they implement the solution and they go back to business saying that, hey, we are done with what you wanted, now you can test it. And then that's how the cycle goes on. You probably have heard a lot of terms, especially not the MBA folks, but the engineers who are sitting over here, like GitHub, CI/CD, continuous integration, continuous development, pipeline concepts, right? So all these are a part of the whole end-to-end deployments of any code for the business requirements. So that's where is the concept of importance of data growth and changes in the storages. Now, as I mentioned earlier, a term called data engineering. So data engineering, what it means is, it's a data collection, storage and transformation and analysis processes for large amounts of raw data, structured and semi-structured data, as well as the unstructured, okay? So data science professionals can draw valuable insights from it, okay? So this is how the normal, regular data flow looks like in a technology standpoint. Even if you are MBA students, if you are going into the business side, most likely, or the marketing, into many consulting firms, like top consulting firms, when you go for hunting for the business, it's like farming and hunting, right? You have to use the terminologies of the business as well as the tech terms. So you should know what exactly the business you are targeting, you are going for. So this is how the data pipelines work in the technology world. They are data stores, they are live real-time data streams, and the data can come also from different web applications which you use on a daily basis. So wherever you move your mouse, wherever you do a web crawling, everything gets captured and everything gets fed to the companies for whose product or whose website you are using. That's why you always get a pop-up of cookies setting, right? Where you have to give your consent. Even if you give the minimum consent, okay, I want to go with the minimum cookies, still they are capturing your data because they have to enhance the services for their customers, okay? And that's how it works. And we, being a data engineers, data analytics team, and the cloud engineers, what we do is that we process all of this data, which is the millions and billions of records on a daily basis. We bring it, we load it depending on what is the need of the business. If we have to do a AI ML algorithms, it will go into data lake. For historical analysis, for the reporting purposes for the business, it will go into the warehouses. And as I mentioned, it depends again what you need in your technology stack infrastructure. It could be a data lake house also, right? And then, as I mentioned, the data can be of two types. One is the batch processing and one is the real-time processing. Batch processing means, okay, this is not very urgent. I can live with the delay in the data for 2 days, 3 days, or maybe 1 day, 24 hours is fine. That's where you're not getting a real-time data, you are running your jobs, your processes at a particular set of time in a day, then you bring that data and then the processing will happen end to end and the reports will come out of that. But there are areas like the fraud detections, real-time transaction approvals, right? Whether you are the right person who are swiping the card, right? You are the person who are logging in. Google immediately asks you when you log in from some different computer, are you the person I'm sending you a code on here, this G hyphen this, right? So that's a real time, okay? So that's how these data, depending on the needs of the business and the technology, they go and sit down and get analyzed by data science teams, business intelligence teams, and the machine learning teams, okay? So if you see, it's a collection, ingestion, store, compute, and consume. So where we are heading, what is the future? So in the last 18 months, mostly every company in the world, they want to be a data and AI enabled, every company. Because every organization outside there, they know the value of the data, and the data is so enormous that it is out of the human capacity to process it, and that's where they want to bring the AI to fulfill the role of humans at certain extent to quickly give the insights out of that data, okay? So data is from a different domains. It could be from a finance, retail, media, healthcare, public sector, and many more. So even if everyone wants to be AI, or more specifically now the organization are leaning towards Gen AI, because Gen AI is a buzzword, and we will see in the next slides a couple of things about Gen AI and where we are trending. So everyone wants AI, but on top of that, everyone wants to be mindful about the security and the privacy issues, because if any company mess up with the security or privacy of the data, especially with the rules like GDPR and the US rules of federal laws, they will have to pay a hefty fine in the millions and billions of dollars sometime. So it's very important to implement the security and privacy on top of the data. And the third problem with the most of the organizations right now facing is that their data estate is fragmented. So what that means, data estate is fragmented. Most of the organizations which are in the market right now, because they are from the years and years, they have a lot of data in silos in their organization. It's all fragmented at different places. Even sometimes a duplication of data. Departments are not in sync with each other. So companies want a single source of truth of their data. Okay, because otherwise, if you don't have all the information at one place, it's very difficult to come to a conclusion what should be our business strategy, how we can enhance the customer experience, how can give the better services to our customer, and how we can also get a return on investment of what we are spending. Okay, so this is the problem here. And on top of that, if you see, companies majorly are mentioning that I don't care about the standard benchmarks. I just want the model to work well for my business. That's all I want. You take care of your AI models. I want the things what I need from you to run my business. So that's where the comes like what is the importance of data and AI in the next 5 to 10 years. So you all who are sitting right now here, you are going to witness the best era of your life when this technology bring a revolution and evolution. Okay, so before I go into the next slide, which actually I wanted to go later on, but I wanted to put a question. How many of you know when the AI word was coined? Really, it was introduced in the market. Anyone in the floor? How many of you are here who knows AI, ML, who are working on it? Anyone is there on the floor? No? It's all management? Okay, engineering. So, okay, that's fine. So, actually I wanted to know, at least you should be knowing this, guys, because AI is the next big thing. It's already there from last 10 years, 20 years, but now it's picking up the pace, and because of this new Gen AI on top of that, it's like, and don't Google, guys, if somebody's Googling on the phone. So, yeah, so 1950, the AI concept came into picture, but in 1955, the person named John McCarthy, he introduced the artificial intelligence term, okay? So, probably we have heard recently, but actually it's there in the market from a very long time, but it have taken the pace recently, okay? So that's where I'm going to talk about AI ML evolution and the use cases. So artificial intelligence, what that means, it's like engineering of making intelligent machine and programs. The computers, the calculations they do, the many others work which are repetitive, which need human labor, which can be automated and make, right? So that's where the AI came into picture, to make the thing automated, which a human should not be spending time on, right? Then it came a machine learning concept, which is under the umbrella of artificial intelligence. So artificial intelligence is like umbrella, and it have a lot of departments. Machine learning is one, deep learning is one, generative AI is one. So then came the era of machine learning, where we said, hey, it started in 1980. We said, hey, ability to learn without being explicitly programmed. So it will help in algorithms, and many machine learning models, defined models are there in the market, which majority of the students and the companies use. They keep on using it, refining it to make it usable for their purpose. And then the deep learning comes into picture, which is based on deep neural network, and it was started in 2010 and up to 2017. It's still going on because Gen AI's major background is deep learning. It's a subset of deep learning. So that's how the AI ML and machine learning and deep learning evolution has happened. And where all these AI use cases are being successful so far? In the healthcare, automotive, manufacturing, energy and oil, education, hospitality, finance, logistics, and many more. I have a very handful in this PPT. And how AI has helped in the healthcare? It helped in detecting the diseases very early, and also it helped making a personalized health plans for each of the individual. That is a transformation happened in healthcare. And not only that, if I have read so many research papers where people are doing, the scientists and researchers are doing, like how to understand or diagnose the breast cancers in a very early stages, or any other cancers and any other health problems. So a lot of researchers are going, and that is all based on the AI. Next thing is, which is like finance, from the industry from where I come, right? We have AI models to predict market trends and detect the fraudulent activities. And transportation, you probably have all know that Tesla and all the self-driving vehicles, right? They all are based on the AI based, right? So there are many more advancements in AI, but these are the couple of things which I wanted to bring in this forum. And what then came the Gen AI, generative AI, the buzzword, and what are the tools, right? So what is generative AI? I mean, again, I think you probably be knowing that. It's an AI system that can generate new content. It's not old content, where AI was just mimicking what you were doing earlier, what a human was doing earlier. You exactly the job which human is doing on a day-to-day basis, they automated that, okay? But Gen AI can generate a new content on the data models or data which they have trained on, okay? So they take the history of the data, they get trained enormous data, and then they give the outputs, and they detect what should be the matching, what is the expected next word out of that, okay? So that is where, the feeds the content they generate could be a text, images, music, based on the data they have been trained on. So text, we all know ChatGPT. I know every one of you might be using ChatGPT on a day-to-day basis for generating something or other, right? So that's where generative AI has revolutionizing the world. A prime example is, we know open AI companies, GPT-3. Now they have already also released GPT-4, as well as the GPT Mini O. If you have seen that, new drop down is there. But there is a difference in both of them. GPT Mini is on the basis of small language models, whereas the earlier GPT is on the large language model. Okay, so small language model means it's like dedicated to a certain specific area, and then it's not trained on a very enormous data, but on a subset of data. Okay, so this is how the evolution happened. If you see here, like AI was the umbrella, and within AI machine learning came, then deep learning inside a subset, and then within deep learning we have generative AI, which is right now a buzzing thing, and it's going to be a future. But I tell you, like, still majority of the companies, they are still working on it in the lower environments. Very less things have gone into production. Okay, and most of these, you see the revolution which have happened in the last 2 years. The product and tools which came into the market, which got very popular, are the ChatGPT, regular one, and then ChatGPT-4, Scribe, right, and Dell E2, which works with the text, the images, generating images, and then this one is the GitHub Copilot. So GitHub Copilot is very famous in the industry, especially for the technologists, the developers, the architects, right? And majorly it's for the developers, because what it do is that it will help the coders on the fly to let them know whether he's writing a code. Even he support you in writing a correct code. He supports you how to deploy your components, your code into the other environments, production, and it will tell you the anomalies also where you can correct. So it super boosted the efficiency of the developers. They made a normal developer to a good developer, and the good developer to a superb developer. That's the beauty of the AI. Okay, so now why everyone wants Gen AI? Because, as I mentioned earlier, it can assist you in creating, writing, composing music, and much more, right? So what is the competitive advantage? Companies see Gen AI as a way to innovate and stay ahead in the competitive market. Okay, nobody wants to left behind. You have seen in the past, we moved from traditional technologies, but then the companies were struggling to maintain their own data centers, right? There is a concept called operational expenses and capital expenses, right? Have you heard about it? OPEX and CAPEX, right? So operational expenses, and so people wanted to cut down on the investments which they are doing on their servers, their data centers, and that's where the cloud computing came into picture, where Google, starting with AWS, and then Microsoft Azure, and then Google came into picture, where they say, hey, you don't have to keep your data in your system, you can put it in our data centers, and you just pay by usage, and it will reduce your cost very, very enormously, right? And that's how they sold the model. And in the cloud also, one more good thing is that they have separated the compute and the storage. They said, hey, you have the data, you put it here. Whenever you want to run your functions, your code, you just go use the compute, and whenever you choose or use which part, like computer storage, that time only we will charge you. Okay, so that's the beauty of that cloud computing. So that's where the company sees now Gen AI. It's a rush. When the cloud computing came, everybody wants to onboard it into that cloud. Now AI and Gen AI, nobody wants to stay behind. Every company want to take the best out of it. And this is what I have some facts over here. Like GPT-3 data, GPT-3 OpenAI model was actually trained on 570 GB of text data from a variety of sources, including books, websites, and articles. And this vast amount of data allows GPT-3 to generate highly sophisticated and contextually relevant text. Okay. What other thing which have made the Gen AI very popular is when this ChatGPT-3 came in the market. If you see here the history, majority of the applications which came into the market to attain the 100 million users, it took Telegram 61 months, Pinterest 41 months, Instagram 30 months, and now Chat GPT is just in the 2 months they capture the market. And 100 million users is not a small thing, it's a big game, right? So that actually, why I'm showing this is that this actually, it tells you where we are heading, okay? What is the future is going to happen. So you should all be prepared for what you are going to see in the future, okay? But right now, as I mentioned, like 85% have not been made into production, which means like most of these Gen AI solutions or use cases, only 15% have gone into the live environment. ChatGPT 3 is one of them. 85% companies are still using in testing, development and testing. They are not very confident to move forward for deploying this. So when any technology comes, right, it brings the advantages as well as disadvantages. Previously, before me, Dr. Shen was there, he also mentioning the same thing. So advantages and disadvantages, yes, technology work for us, but at the same time, there are certain issues which we have to deal with to make sure we are doing the right thing. So first, I'm talking about challenges in data first of all for AI. Before we go next, what are the challenges with AI? Okay, but first, what are the challenges with data? This one I mentioned in my previous slides. One major challenge is that data are available in silos and fragmented in different parts within the organization. Okay, and different departments, they are not handshaking. And that's why companies are not able to leverage the value of the data they have with them. Secondly is the data bias. So data bias means it's a big thing. As I mentioned earlier, if training data is not representative of the real world, the AI model can produce biased or discriminatory results. Okay. And the third one is security and privacy concerns. So data security and privacy are the paramount, especially where the data breaches are common, ensuring that personal information is protected and used ethically. So if you see here, global security and privacy regulation is on the rise. AI need to be regulated. Data privacy is the need of the hour. We are facing a lot of cyber attacks, right? What that means is there are a lot of concerns. You can lose the data. When your data comes from the web applications to the warehouses in your center, there are a lot of hackers are sitting over there who can attack on your data when the data is in motion. So there are two things in the data. One is data in rest. Sorry. Okay. So I will try to wrap up fast. Okay, guys. So data and security concerns we have to deal with, AI regulations, data privacy and cyber attacks, and that is where we need a regulated environment so that the companies should not get fined by or penalized by the governments. This is not working. Okay, thank you. And so we have seen the data problems. Now what are the pitfalls of AI? So hype versus reality. There is a lot of hype right now in the AI. You know, AI can pose ethical and legal concerns, privacy issues. There could be AI hallucinations. AI might give you the wrong answer, but the way the conviction power it have to say that whatever I am saying is truth is very much available there. So AI might generate the unexpected incorrect outputs, okay? And AI and human collaboration. So AI is not going to replace the humans. As I mentioned earlier, it could automate certain tasks where the humans don't have to put their brain. They can do much better things, right? So that is where AI and human have to go in hand for the leading the better decision making. There is a pitfalls of AI I have mentioned over here. There are some concerns on the governance, ethical issues. You can look into that. And now for you guys, I just wanted to give you little highlights where the market is getting forward. So this is where we are heading. So if you see here in 2020, this is the I think this is pretty hazy for you guys maybe, but yeah, this is the $1 billion terms. If you see in 2020 we had only a market size of $93 billion. It moved to in 2024 $184 billion, and this is what the projection is, where we are heading to. So majorly if you see the yellow part here, this is where I think the majority of the investments are going to happen, which is machine learning, AI, robotics, and then other areas within the AI. Okay, and this is the Gen AI investment. So this was the full AI area, but within AI you have the Gen AI, and this is the investment progression you can see in the coming future in $1 billion. And these are the sectors like healthcare, finance, manufacturing, business and legal processes, transportation. They are going to get a huge and massive investments in that area. Now you can ask, okay, Robin, what is the Asia Pacific growth in India? So if you see in Asia Pacific, India is at the forefront in investment in the AI market, and you can see here like machine learning is going to have a biggest investment in the $1 million if we count by technology, and by business function it could be marketing and sales, then finance and accounting, and then other sectors. So AI race is begun, guys. Everybody is like, as I said, that they want AI, they want data in their organizations. Many startups are heading for the investments in the AI world. You can see here the listing ranking of the countries who are investing in AI. India stood at the 7th position by the 2023 AI index report, but I heard recently it might have reached to the 5th in the position. But the major investments are going to happen in United States, China, UK, Israel, and Canada, and followed by India. So here I just finished my the explanations on like what I wanted to share with you guys, where we are heading, what is the value of data in the AI and machine learning world, where we are heading, what are your future opportunities. So I really wanted to show the statistics so you get a ease on nerves where you have to invest your time. Okay, and now the students over here, maybe I thought you probably, most of you might be knowing product based companies and service based companies difference, but there are two different types of areas where you can make your future, and that also I wanted to discuss. Product based companies are the companies who actually create a product for you guys to use, and the service providers are like Infosys. So product based is like Google, Adobe, Microsoft, Nvidia, right? They all are product based companies. Okay, but what about these companies? These are service based companies who offer a consultation, who can send their employees, they hire the employees, and they also lend their employees for the innovative work in those product based companies. So you have a future in the two areas. You can go into the service based companies, you can go into the product based companies. It depends like what is your interest into. Only thing is that I tell you honestly speaking, like for learning purposes both are great. For overseas opportunities, I believe service based companies are on the top as compared to product based companies. Product based companies also send you to have overseas experience, but little later, not immediately, but you can get those opportunities in these companies pretty fast. So that is where the differentiation stands. And definitely compensation, definitely left side always on the top in the compensation as compared to the right side. Okay, so somewhere you have to compromise what are your priorities. Okay, where you want to see your future, how you want to set up your career path. Okay, so in the last, my message to all audience over here are the learners: never stop learning. Okay, because life never stops teaching. Okay, so I hope that this will help you for the rest of your life. If you want to connect with me, this is my LinkedIn. You can scan my barcode, the scanner. You can ask me any questions, and I'm happy to answer your questions. So I'm being told that most of you guys have a class you have to attend. So if anybody want to ask anything, I have opened the floor for you guys. You can go ahead. Who wants to leave, they can move. Yep. And I believe this session would be informative for you, because most of the people, they don't talk about this level of details. Because you are from the management or from engineering, which you are focused in your curriculums. But this is the real market. When you go out, this is something you will come across, which you might not get exposure right now while being in college. Okay. That's one. Thank you. Yeah, you can reach out.
Yeah, mic. Do you want mic? Sir, mic. So they have a question.
Good afternoon, sir. I'm Kavya, an MBA student. So, what are the steps can student take to stay updated in the recent technologies and trends?
Very good question. Oh, I love the mic. Okay. Yeah. Yeah, guys. Thank you for asking question, Kavya. I really appreciate it. Somebody took the courage to stand up and ask the question. Yeah. So, see, there are a lot of ways to stay up to date in the market. One thing is you have to be on the LinkedIn. You have to join the right groups. There are a lot of technology groups are there. You should go into those groups. They are continuously talking about what the latest trends are going on in the market. You go and Google like AI trends or AI statistics. You will find website like Statistia. You will find website which can tell you where our investments are going on, AI growth, which area, which sectors are going on, and which technologies are in demand. I actually had it. I am not sure if I showed you in that my PPT, but I had a link there somewhere. I can share you if you guys can send me. But that is one thing. And always, I think right now there are a lot of. I think my time was different when I was not having much mentors, and the social media was not very popular. Now, if you go to Instagram, if you go to LinkedIn or YouTube, there are dedicated channels. There are those influencers who are just talking about the latest trends and technologies or what is happening in the market. Okay, and not only in the technology, in the marketing, in the manufacturing, everywhere you will get to know the latest things. And one more thing is that I think I mentioned earlier is that keep on reading books, keep on reading newspapers to stay current what is happening around you. That is very important.
Sir, and I have another one. How is your MBA knowledge has helped in your role, like leadership's role?
Okay, so actually my background is like more of a computer science engineer, and then I did my CDAC from Pune, and then I have done MBA but not a regular but on a part-time thing. So yeah, so it's a combination of things because I was into a job, but yes, the leadership is not like something. I do learn the concepts, but I really learn the things on the job. Evolved from a junior developer to a senior developer to the lead consultant to principal consultant to manager, senior manager, now VP. And that's how I learned on my job. I always try to listen to my leaders, what message they are saying, how they are talking. And then I always used to ask questions to them. Okay. So that's how I learn from them, and slowly, and this is not a race kind of thing. You can only learn these things while on the job. Whether you go to PwC because you are a marketing MBA professionals, so mostly the top consulting firms might be your target. There are medium-sized consulting firms too. The top is like I know that Deloitte, PwC, KPMG, and many more, right? So yeah, if you go there, like they will like brush you like anything. They will make you work hard, but then once in the next 5 years you will feel the difference, the point you went inside and the point you spent 5 years over there. So that's how you learn gradually, because when you go inside, there are a lot of cultural things they teach you. They are in-house leadership skills trainings they do, and they put you in the real world environment. Okay, so leadership is like they send you to different customers. You will pitch in. Maybe initially you will feel hesitated. You might feel that I'm not sure if I can do that or not. But later on, with consistency and perseverance, okay, continuous perseverance, you can make it. That's how you learn. So you might heard a lot of jargons like servant leadership, accountability, compassion, empathy, right? But that all comes. It's one thing is like you are born with that culture. You have been grew in that culture. That is one thing. That is where you probably have seen like so many people who are very very intelligent, and when they try to go into the top companies, sometimes they're not able to make it. And the answer, which internally in the background, what they say is that not right fit for the culture, right? And this is because of these reasons. Like sometimes it's not always about you are on a top in studies, but you also have to build your skills in the other areas.
Thank you, sir. Good afternoon, sir. I'm Bhavani from MBA department. Actually, I too have two questions for you.
Okay.
Firstly, what are the key areas of knowledge should student or focused on who want to pursue in data engineering and analytics?
Okay. So I tell you, like, first the distinctions the companies have. Okay, what are different areas company have, and where majority of the MBAs or goes as and work in my and they can help out if you have a specialization in the, let's say, business analytics or data analytics in that area, right? So every company have, most likely, if I take my current example in my current organizations, so we have a area, we have the business, we have the product owners, and we have the technology teams. Okay, so business is something who are the people who have a domain knowledge of that domain, healthcare, financial, any other domain you can take out. Okay, then there are the BAs or the product owners who actually take the work from, understand the work from businesses, and then take the requirements and then give it to technology teams. Okay, so majority of the time these tech teams, they actually interact with the product owners or the business analysts rather than directly interacting with the business. Okay, so that's the differentiation. First of all, you have to understand. Now coming to the data engineering side, yeah, so data engineering is not like something I have seen, like now it's coming as a courses from the last couple of years, but earlier it was never used to be. People used to get inside. I learned C, C++, Java, and then I went into the company and I heard data engineering, which was like a Chinese for me. I never knew that what was that. I got so scared. What is data engineering? But eventually I learned it because I had a habit of learning, as I always say, keep learning. Yeah, so data engineering, you can do in-house projects, like you can take some sample data, you can read some use cases from the existing open sources. Nowadays in the environment, GitHub environments are there, so people can upload their codes and they do the processing of the data to try their hands on. But from the MBA standpoint, I think like you need to know the statistical models, like how to do analytics from the historical data, what all other models you can do, how you can communicate in the business language of data and analytics with the business team, right? That is more important. And again, like I said, there are a lot of learning platforms right now in the market. You can just go and subscribe, and there are free education. Stanford, MIT, they're giving a lot of free courses. You can just enroll. They're not even charging a single penny, and you can get a lot of insights, more than me. They can give you the insights, but yes, that is what I can guide you.
And okay, sir, thank you. And secondly, what is the importance of cloud computing in today's technology landscape, and how it will impact on data engineering?
Yeah, so another good question. Like so cloud computing actually picked up the pace in the last, I think, more than 8 years. As I said, that there are many cloud providers, but AWS, Azure, and Google, I'm not promoting them, but they are the one who are really in the market. And majority of the companies, so cloud computing, it helps organizations to reduce their expenses, as I mentioned earlier. You don't have to put money in advance to buy certain things, your data disks, or create a in-house data stores to store the data. And that's where companies save a lot of money, and they can divert that money into some other R&D work. So that's where cloud computing have been popular, and it is growing because everybody want to keep their data in the cloud warehouse. But again, there is another thing is that you can't just move everything to cloud. There are some financial regulations by the governments of different countries. Every country has their own data privacy policies. In the US, I work for, we give data to Federal Reserves, the regulatory bodies. So they have their own security and privacy policies, right? So you can't put the confidential data on the cloud because we still are in process of trusting that. Maybe the non-confidential data can go there. So that is the thing. You can have a lot of personal information which can hamper you if it gets hacked. Like PII, personal identifiable information, what we call is that, right? So that is something which you can, like, it's like a tax number, your SSN in the US, your very, very personal details which can be misutilized. Okay, so that is something might not be good in a use case to send it to cloud.
There will be negative and positive impact.
Yeah.
Okay.
Yeah.
Thank you, sir. Thank you so much.
Maybe I can take one more last question and then we can wrap up. So earlier nobody was asking question and now everybody got a confidence. I like that, guys. Yeah.
Sir, what emerging technology which impacts in next 5 years?
Yeah, so emerging technologies, there are a lot of things. As we already know, AI and Gen AI picking up the pace in every sector. So they are going to help. So what impact is that, like, they are going to divert the human being into a much better side than keeping them frustrated to do the redundant work again and again. I think that is the idea of bringing these emerging technologies so that it can help the humankind so they can do a more meaningful work for the society and for themselves rather than grinding themselves in the same thing, right? So that and emerging technologies, like in every sector, I think if I want something very immediately for my personalized solutioning, right? I mean, and if I need somebody in the out of hours, let's say I need some banking solution, I need some banking advice, and it is already the bank is closed. So that's where I can ask these AI tools, robo advisors are already there in the market, but it's going to enhance more that you can ask it. You don't need a human assistant for something which can be answered by the AI, right? So I think, yeah. So I mean, it will give you more opportunities. For example, let's say a bus driver, right? He's every day driving a school bus, right? But maybe down the line in 2040, by 2050, you might see bus is autonomous, right? They don't need a driver, but that doesn't mean that driver can be used for other things. He might be able, his job duties might change, but we still need a human touch, empathy in the society, and he probably will start cheering the kids over there. He will ask the stories, how was their day, which can bring the more cultural touch in that one. So that's what.
Thank you, sir.
Yeah. Thank you. All right, guys. Thank you.
Thank you so much, sir, for your enlightening and inspiring words. Your address has truly set the tone for our event and has given us so much to reflect upon. On behalf of the organizing committee and everyone present here, we extend our deepest gratitude to you. Thank you so much, sir. Thank you, one and all. I request the participants of the conference to kindly stay back.